will be a star freelancer. Learn new skills. Set your goals. Increase your skills. Browse over 100 plus videos and ebooks. Jump to starfreelancer.eu.
Let's look at the content of this course. The first thing we did is to set up Python. Then we look at if Python 3 is the default in your system or Python 2. If it's Python 2, we guide you on how to make Python 3 the default. Then from there, we learn how to install Python. This is how to use the Python shell. Then how to set up Python with Sublime Text and how to set up Python with Jupyter Notebook. Then we look at Python variable. Then we look at different Python operators, as you can see in this place, such as arithmetic, assignment, bitwise, left and right, bitwise, logical, comparison, identity, and membership operator. Then we look at Python comment, then Python data types. The next thing is Python list. So you can see in this place we have a lot of things in Python list. We started from the scratch. What is Python list? We look at different dimensions of Python list from beginner to intermediate level. Nothing is assumed here. As you can see in this place, preset by preset, and there are a lot of challenges and solutions with the codes. Challenges and solutions with the code. A lot of them. Once you understand Python list, the next thing you should understand is what? Tuple. We look at Python tuple. What is tuple? Creating a tuple. Is tuple immutable? Is tuple ordered? And so on and so forth. After we finish all this theoretical part, we look at different challenges and solutions in tuple. So the next thing was what? Dictionary. You can see a lot of things we did in dictionary, from the word very basics in dictionary. Immediately when we finished all the theoretical part of dictionary, we dive into different challenges and solutions in dictionary. Then we look at Python set. So many things we covered what? In Python set. As you can see in this place. Then we look at fuzzy set. All this. Then we move to Python string. You can see in this place a lot of things we covered in Python string. A lot of things. Then a lot of challenges and solutions for you to be able to understand it better. Here we have how many? 42 challenges and solutions just for Python string. Okay. Then we look at casting in Python. From casting we move to Python container. From container we move to Python range. From range we move to for loop. From for loop now, because you need for loop to understand all this, we move back to what? Python range function to do a lot of what? Exercises. Here we move back to for loop to do exercises. Then we move to if else statement. So you can see in this place. From there we move to input function. Then while loop. From while loop we move to what? Print function. From print function we move to list comprehension. See a lot of challenges and solution in this place. Once you are through with this now, the next thing you should do now is to use what you have learned so far to do some what? Projects. Project on vowels and consonants. Then days in month. Another project on media of a given number or pattern. Number of digits in a given number. Multiplication table. Divisible extended. Location of the result of sum. All these are what? Different projects. Then counting alphabet and numbers in a string. Then we look at another project or sum and average of any given number. Once you are through with that, now we move to the advanced part of Python, such as what? Function, then nested function, variable-led argument, keyword argument, recursive function, global variable, lambda, map function, generator, Python modus, Python PIP. Then we look at object-oriented programming in Python. That is Python classes. Then we look at inheritance. From inheritance, we look at what? File handling in Python, exception handling in Python, zip file, pickly, JSON. We look at regular expression in different what? Dimensions, such as meta characters, special characters, then set characters. Then we look at date, time in Python. From there, we move toward graphical user interface in Python called Tkinter. So you can see in this place from Tkinter, we use all the knowledge so far to do more projects such as guest number game, Agman game, YouTube downloader, password generator, then digital clock. At the end of this course, you should be able to create your own project and you'll be able to use Python effectively to work on projects. Without any further ado, let's get started. Our target is to have Python version 3 installed. Okay? The first thing you need to do is first of all check if Python is installed in your system. This I will show you how to do. This is the first thing you must check. If yes, check the version. If Python is installed in your system, check the version of the Python. If you find that it's version 2, after you issue Python --version, which I will demonstrate, don't be in a hurry to conclude that you only have Python version 2 installed in your system. It is possible you still have version 3, maybe currently the system has selected version 2 as a default. So all you need to do, you have to issue Python 3 --version. Remember, if you put this, you will either have version 2 or version 3. This one is telling us that what? This is the default. That is, if you have Python installed in your system at all. Okay? But after you issue this command, you find that it's only version 2 that is displayed. Don't bother. Go ahead and issue this command too and see if version 3 is also available. Maybe it wasn't selected as a default. So if version 2, also check for version 3. No version 3 at all, then you have to install it. Okay? But assume you have version 3. Still check if it is the latest. If actually the latest, but when you issue this command, what you see is this, then we have to make version 3 the default. Let's go ahead and do this. If you have the latest Python, if you use this command to verify that this is the latest Python, but when you issue this command without Python 3, what you saw is not 3 point, but 2 point. It means that your default Python is 2 point. How do you make this one your default Python version? All you have to do, you need to check all the available Python 3 in your system by issuing this command. Once you issue this command now, it will show you all this. Then you have to choose the particular one you want to use as your default. Currently, you can see that this is my current version and it is the default. That is why when I issue this command, it is telling me that this is your default Python running on this system. For you, you might not be lucky. It might be that it's a lower version. But if you issue this command, you find that there are some other higher versions running, but not the default. When you issue this command, you can change it to the one you want to change it to. For instance, if you want to change it to 3 point, you simply have to issue this command. Once you enter this now, if you come back and issue this Python version, it will tell you that now it has been made a default Python version. To run Python program, the first step is to make sure that you have Python installed in your computer. How do you test for that? You issue Python --version. If you are using Windows, the same thing. If you are using macOS, the same thing. Just go to your terminal and issue this command. If I enter, it's telling me that I have the latest version of Python as at the time I'm running this command, 3.9.4. You issue this command, it show you version 3, as you can see. That is good. But if it show you version 2, that is Python 2 point something, it is possible that you have version 3, maybe the default currently is version 2. To confirm that you have version 3, simply go and issue Python 3. With this, you can double check if there is Python 3 installed in your system. If you enter this and you see that there is no Python 3, then you have to go ahead and install Python 3, the latest version. But if you have the latest version and still when you issue this command, it's still showing you version 2 point something, it means we have to set version 3 as the default. Let's go and check how to download or how to install version 3 in your system before we go to setting up version 3 as the default of your Python program. If you are using macOS, you can simply issue brew, install Python to get the latest version. Assume I enter this, it will process, but it will report to me that I already have Python installed in my system. You see, it's a warning is already installed. This command will install the latest Python in your computer. But assume you don't want to follow this method, go straight to python.org. You come down here and click on this. It will show you this. Come to this place. If you are using Mac OS, click on this to download. If you are using Windows 32-bit system, click on this. Or if you are using 64, which I believe you should be using, you click on this. Once you download, double click on the installer and follow the normal process of installing every other program. But I'm not going to do that here because I already have it installed. This is the first time you want to run Python. What is the basic way of accessing Python? What you need to do, just type Python here. On your terminal, type Python. It will open the Python shell for you. This is a Python shell. You can run what you want to run, the basic Python program here. For instance, I can do arithmetic operation. Say 1 plus 1, it says 2. 4 plus 4. 4 minus 2. 10 divided by 2. 100 raised to power 2. And so on and so forth. So you are already running Python now. I can say S is equals to 3. If I put S here now, say S is 3. What of Y? Assume Y, there's nothing in Y. I want to check for Y. See, name Y is not defined. See, this is Python shell, but this one is not actually the best way to run Python. What you need to do, you can open a text editor, a separate text editor. You save it with a name .py as the extension. This Sublime Text is a text editor, but it's a little advanced. You can use any text editor. I will save it as test.py. Remember when I was using the shell, I just run direct without putting anything like print. Like for instance, if I put print here now, I say 1 plus 1, it will give me 2. But if I say 1 plus 1, the shell will still forgive you for not putting print. But it's not the same thing with other environment like this. Must put print, then you put like 1 plus 1. Let's save it now. Go back to terminal. Then we're going to say Python. Then we put that file. Okay, this is the location of this program. Then I run it now. Let me also type another thing. For instance, I don't want this. I say print for me. Welcome to Python programming language tutorial. Then I save. I still run this Python. Then the location of the file. Then you run this now. If I enter, see, welcome to Python programming language tutorial. But what about Sublime Text is that if I say Ctrl B, it will still give me the same thing. It's a little advanced than normal text editor. For instance, if I still want to print, assume I say okay, 2 raised to power 4, I can say Command B or Ctrl B. See, it's giving me the first one. It's also giving me this. Let me go back to say print, you are good. Then I come to this place, I say print. I go back to the terminal, they run it again. See, this is the first one, as you can see, the second, the third, and the fourth. Okay, so these are the two things we have used now. First, the shell. Second one is an editor with what? The terminal. The next one we're going to look at, which you will be using all the time, is an IDE, which is Integrated Development Environment. Now you are ready to program, and you want to take your programming serious. You need an IDE. Integrated Development Environment. If you go for that, you will see that we have idle. This, the shell we used just now, plus an editor. It's still basic and very good. We have PyCharm, we have Spider, we have Eclipse, we have Visual Studio, we have PyDev, we have Atom, and several of them. We are going to use Jupyter Notebook for this course. Once in a while, we run to Sublime Text. It depends on what we are doing. That doesn't mean you can't use any of them. You can use any of this one. They are very powerful. And the more you use them, the more you love them. So I'm not going to dictate to you the one you should choose. Anyone you are comfortable with, you can go ahead and install. In the next video, we are going to look at how to install Jupyter Notebook through Anaconda. After that, we install the Sublime Text. Hope this is understood. Thank you for viewing. So to install Sublime Text, first of all, you Google for it. You click on this, the first link. Then you can download the one that is relevant to your system. For me, I use macOS. I click on this to download. Now it's downloading. We're going to wait for it to download. Then we simply do simple installation. Also, you can download any other one here. If you are using Windows, if you are using Linux, it depends. Let's wait. Now it has finished downloading. Simply double click. You can go to your download folder to run this file. All I have to just do now is just to drag a drop here. Then I run it. Simply do this. It's asking me, do you want to replace it? Just stop. That is the first phase. The second phase, once you finish installing it, you only have Sublime Text installed, but it doesn't know how to access your Python. Why? Because you can use Sublime Text for a lot of programming language. If I come to this place too, as a build system, you see, you can use it for C, C++, Django, Java, C, Elag, and so on and so forth. Therefore, you have to assist Sublime Text the way you assist the baby to locate something. How do you do that? Simply tell Sublime Text to build system for you. So you come to this place now, come down, say new build system. It will open this place for you. Copy and paste this code. I will drop this for you. All you have to do after this, you simply save it, because currently it's what? Untitled. Command S, it will move you to this location. Then you can save this. Let me just say Python 3a. You can put any name here. I already have it. I'm just doing this to separate it from the one I had before. Okay. Or let me say Python 3b. You can see I have 3a already. I'm making this one 3b. Then I save. I will close this. Let me open this. I will save this as anything you want to save it. It must not be in this location this time. Tutorial.py. It will always give you this. Just cancel. Now let me just run basic Python. Let's just say print hello world. If I run this now, I need to tell the system the one I want to use. I will come to this place, tool. I will go to build system. I will tell the system that this time I want to use Python 3b. You can see this is the default now. I selected it. Now I want to change it because I just want to show you. Then I can run. Command B, see, it's telling me what? Hello world. All because I've told the system or Sublime Text where to locate Python with the help of that code I showed you. I'm going to save the code for you. You can copy it. I use it to also build your system if you want. To install Jupyter Notebook, the first thing you need to do is to first of all install Anaconda. Search for Anaconda. Click the first link. Now it's downloading. So we are going to wait for this guy to download. Then we continue from here. So next, go and double click on this, on the download to start installation. This package will run a program, determine if the software can be installed. Then we click next. So this is the same thing we do for Windows. All you have to do is just be clicking next, next, next. Very easy to install. Although I've installed it before, so we select this to continue. I say you should install. So you have to do the same thing for Windows. It's very straightforward. There's nothing difficult about it. Okay? Through Anaconda, we have access to Jupyter Notebook. So that's why we have to install Anaconda first before we can have access to Jupyter Notebook. It's asking me, installer would like to have access to file in your desktop. I say okay. Okay. Next, we click continue. Finish. The installation was completed successfully. We close. Next, let's open Anaconda Navigator. Then we enter. It's opening. So the next thing you have to do when you have access to this window, click on Launch Jupyter Notebook. You click on this. It's processing. So this window is open for us. So all you have to do now is to click here, New. Then you click Python 3. Because we are using Python 3 for this class. Okay, now you can do what you want to do. For instance, let's just do basic arithmetic. Once you type it here, we call this one a cell. Then you can run to get the output. Hope this is understood on how to install Jupyter Notebook. Thank you for viewing. What is variable in Python? A variable is a reserved memory location to store values. How do you define a variable? To define a variable, you simply give the variable name. It could be anything. Say x, for instance, is equals to 20. Once you run this into Python, a location in the memory will be allocated to 20. And whenever you type x or you want to print x, it will give you 20. It's like a box. You call this x I want to put 20 inside this box. Let's see. If I say s is equals to 20, it means this is a variable name. This is the value of that variable. If I run this, then I print x. You see, s is 20. If you want to know the address of x, say id x. If I run this, see, this is the address in the memory. If I say y is equals to hello world, this is a string. Also what? Data type in this memory location. And the name of that memory location is y, which is what? The variable. If I say what is the location address, to tell me what is this. You can see this is the address, different from this address. So all these are variable. A reserved memory location to store values. Okay? This is very crucial in Python. What are the rules of naming variables? The number one rule is a variable must start with what? A letter or an underscore. How do I mean? You can say underscore var is equals to 89. If I say underscore var, remember with the help of Jupyter Notebook, even though you don't put print, you can see what is in this location. If I run this now, it's telling me what is 89. Or you can start with simply just text. I can say var2. After the variable, I can put 2, I can put another thing. But you can't start it with a number like this. 2 var is equals to, say, 34. If I run this, see, it's giving me error. So two things you must know. The first thing, either it start with just a text like this, say equals to 34, or it start with what? An underscore. That is the first thing you need to know. As I said again, you cannot put a number to start what? A variable name. Another thing you must know is that it must be what? Alphanumeric. Once I say var, I can put numbers in between. I can put this. This could be a name. Alphanumeric. Let's say I say 67.9. It's allowed, no error. If I run this, it will give me the value in that variable. If I say what is the address, to still give me what? The address. Three things we have seen now. First, it must be a letter A to Z. It's allowed. Or capital letter A to capital letter Z. For instance, I can say a var equals to 300. If I run this, no error. What is a var? Say what? Is 300. This is just assignment. I am using this to assign this value to this variable. I use this to assign this value to this variable. I use this to assign this value to this variable. In Python, this is not equal to. This is what? To assign. I use this assignment symbol to assign this value to this variable name. In mathematics, this means equal to. In Python, this is for assignment. Another rule is that variables are what? Case sensitive. Okay? For instance, I say var is equals to this. If I say a var, it's not the same thing with this. They are not the same. If I run this, for instance, I will not have this. See, var is not defined. But if I put a here now, it will tell me what? The value. So they are different. Very case sensitive. Even though I make a mistake here and I put capital letter R, it's a different ball game. See, this name is not defined yet. If you want to assign something to this name, you can go ahead, but don't think that this and this are the same. Okay, if you run this, you have what? 80. If you run this, you have what? 300. Two of them are not the same. So variable names are what? Case sensitive in Python. You may want to say, for instance, my variable, for instance, as a name. You can do something like underscore my var, or underscore my var. You can put underscore in between, like my var or my var. You can do it like this. Okay? What you cannot do, as I said, you can say, for instance, 3 var equals to 40. Let's run. Cannot. Invalid syntax. That is the error. Okay? Another thing you cannot do is assume you wanted to write underscore 2. This is allowed, but you can't use what? Hyphen. It's not allowed. Cannot assign to operator, because this in Python means minus. For instance, I know this is what? A var. If I come to this place, I say -2, or like this, the way I did it here. If I run this now, see, I'm having a value, meaning remove 2 from what is already in this place. That's why you cannot use this one to assign what? A name. But if you say underscore, that is not a variable name. These are the naming rules. Also, you can't do something like this. Okay, for instance, my var is not allowed. You have to join them together. There shouldn't be any space. Or you say var 2 or 3 equals to 4. It's not allowed. If you want to use them together, either you move it like this or you move it like this. It's allowed. But if you give space, you are going to have invalid syntax error. Okay? So this is all about variables, how to name them, what it is. Hope this is understood. Thank you for viewing. Let's look at Python arithmetic operators. These are the arithmetic operators in Python. There is the plus, the minus, the times, the division, the modulus, the exponential, and the what? The floor. We are going to look at each of these one after the other. Let's start with plus. If you say 3 plus 2, you agree with me, is 5. Jupyter Notebook helps us put print behind the scene. So if I put it like this, I'll have this. If I say 3 plus 2, I will still have the same thing. Here, there's invisible print behind the scene. If you are using other IDE like Visual Studio, definitely you may have to put print before the expression. You agree with me? This minus 3 will give us 7. Subtraction. 40 minus 20 will give us what? 20. These are what? Arithmetic operators. The way you use them in mathematics. What if you want to multiply 2 values? I simply say, for instance, this will give us what? 12. Using what? The asterisk. We can also say 12 multiplied by 7, for instance. You see, this is a value 84. Multiplication what? Operator. What if you want to divide 12 by 3, for instance? You use what? /. If I run this, I have 4.0. What if I want to say 20 divided by 4? You see, I have this. What if I say 12 divided by 3? Or let's say divide by 7. You see, I have this in decimal places. I will send this, and we want to do this. I don't want this type. I just want the value, which is 1. I also want the remainder. If you want this actual value, you simply do what? The floor division. That is to say, this over 7. The floor division. You have 1. This part of it. For instance, you agree with me that 5 or 7 divided by 3 will give us 2, remainder 1. If you want the actual value side of it, that's the floor side, you use /. But if you want the remainder, you use the modulus. The remainder, you use what? This modulus. We put 3, you are going to get the remainder part of it. Okay? For instance, 12 divided by 5 will give us 2. Remainder 2. Okay? But if I just want this side of it, I will say what? Floor. That is 2. If I want the remainder, I use what? Modulus. It's still 2. Okay? What if you want to find the exponential of a number? For instance, 3 raised to power 2. You can see what I did? 2 asterisk. That is 9. That is 3 multiplied by 3. What if you want to do 7 raised to power 2? That is 7 multiplied by 7, giving us what? 49. What about 10 raised to power 3? That is 10 times 10 times 10. That is 1000. You see, all these are called what? Python arithmetic operators. I hope you understand this basic expression. Let's go straight for other operators in Python. Let's look at assignment operators. These are the assignment operators. As you can see here, they are what? Assignment operator. What is their work? You use them to assign values to what? Variables. This is a variable, a placeholder for values, and this is 8. And you want to assign this 8 to this variable. You have to use this assignment operator to assign this. Remember, in mathematics, arithmetic, this is called equal to. In Python, if you want to say equal to, you use a double of this. This means var is equals to 8. But if you want to assign, you want to give value to this variable, you use this. That's what we call it what? Assignment, assignee operator. Okay. If I run this now, I have what? If I check what is here, I have 8. It means this guy succeeded in assigning 8. Okay. This is not the only operators we use to assign values to variable. We can also use this. What is this all about? You agree with me that var is currently 8. If I want to increase the value of var by 3, what is done mathematically to say var is equals to the value that is currently in var. That is, whatever that is in var now, which is 8, is inside here now. You know, what is here now is 8, right? Plus, assume I want to put 6. It means the old value, which is 8, plus the current plus 6, add them together to get a new value for var. If I run this, you agree with me, var now will increase to 14. You see? But this is not the way we do it efficiently in Python. If you want to do it in Pythonic way, you simply say what? Var plus equal to, let's say this time 8. It means take the old value of var, add 8 to it, and get a new value. If I run this now, if I check the value of var, now if you put 8 here, you agree with me, it's 22. If I run this now, I say what? It's 22. Instead of doing it like this, we are not doing it like this. What we have just done, we are simply saying, what is the purpose of this repetition? Why not make var to represent this guy and this guy? Then we pick this one, then we put the value. It means we don't want repetition in this expression. Okay? You can also do something like this. Assume I want to go back and remove 8 now. I will simply put minus here. It means this old value, which is 22, remove 8 and give us a new value. If I run this, I say, what is var now? We go back to 14. You see? That is what? This assignment. Remember, we are still assigning values to what? To these variables. Okay? What if we want to say, okay, now I have var to be 14. I want to multiply it by 2. If I want to multiply by 2, I will simply do multiply by 2. It means I will have what? 28. Remember, instead of doing it like this, mathematically, what you should do is to do what? Var is equals to var multiply by 2. Okay? We will still have the same value, but we don't want to do it like this. We simply do it like this. If I run this now, I check var, you see that var is now 28. What about for division? The same thing. If I want to divide this 28 now by 2, instead of doing it the old ways, I simply put this here. It means the old value, which is 28, divided by 2, whatever you have, assign it back to var. If I run this now, you agree with me, I will have 40. If I check var now, it means the new value for var is 14.0. Now, what about if I want to assign, after dividing the value of var by 3, for instance, or the value of a variable by 3, I want to assign only the remainder to the variable. Look at it. I say, for instance, s is equals to 6. Okay, if I check s now, you say it's 6. If I want to put, after I divide the old value of s by 3 or by 2 or by 1 or by anything, let's say divide by 4, I want you to only put the remainder. It means I want you to assign the remainder after you divide by 4. Remember, if you divide 6 by 4, you have 1. The remainder is going to be what? 2. Assign the remainder to x. If I run this, I'm going to have what? Let's check now. You see, I'm having 2. Okay, now let's reassign a different value to x. Say, for instance, s is let's say 9. This time, I want to divide x by 4, but the new value I want to assign to s is the floor value, that is the main value, not the what? The remainder. That is to say, I know that s is 9. I want to divide x but assign the floor value to s as a new value. I want to divide by 4, but what I want is not the division, not the modulus or the remainder, but the floor value. You will agree with me that the floor value of this is going to be 2. That is 2 remainder 1. We want that 2 to be assigned to x. So with this now, it will be assigned. With this, we get the floor value. With this, it will be reassigned to s as a new value. So if I run this now, I check s, you see I'm happy too. Remember, it's all about assignment. This one, find the modulus, then assign the value it has as the remainder to s as a new value, okay? I know that s is equals to 2 now. What if I want to find 2 exponential 4, then assign the value back to x? That is to say, the correct value of x, let's say 2, to make it simple, they assign the value back to s, assign it back to x. If I run this now, if I check s, you agree with me, I will have what? 4. Let's do it again. What if I want to find 3 exponents of this? That is to say, 4 multiplied by 4 multiplied by 4. Assign the value back to x. If I check s now, I have what? 64. Finally, let's deal with this right shift and left shift. Let's first of all see the left shift. Assume you have 12 left shift 2. What this one is saying is that after you convert this one to binary, whatever you have here, shift it towards left in 2 places. Let's see. What is the binary of 12? Let's see here. The binary of 12 is 1100. Okay? That is to say 1100. If you are asked to shift this one towards the left, it means for this guy to go towards the left, you have to add 2 zeros here. 0, 0. That means whatever that was here before has gone towards the left, can be pushed towards the left by these 2 zeros. If you convert this one to decimal, okay, let me get another cell. I will simply say integer, then I will put what I want to convert, let's say in 2 decimal places. I have 48. Now let's go now, I do this one. Let me copy this, I run it, I see if I will also have 48. See 48. What if I say, okay, look at this one, 14, shift towards the left 3 places, okay? If I run this, I have 112. So let's go for 14. Let's see 14. This is 14, right? If you are asked to shift it towards the left by 3, I have 1, 2, 3. Now let's convert this to decimal. If I run this, see, I'm having the same value. Hence, if I already have, for instance, here, for this, I have, let's say W is equals to 14. Okay? Now I said W left shift equals to, then I put what? 3. You agree with me that the new value that will be for W now will be 112, because I'm saying the old value, which is 14, convert it to binary, shift it to the left by 3. If I run this now, I say what is W is 112, just the way I explained it here earlier. Now let's look at right shift. Okay, if I have, for instance, 48, I want to right shift it by 2. What is that? The first thing I need to do, what is 48 as per binary? Okay, 48 as per binary is, this is 48 in binary. Now we are asked to shift it towards what? The right by 2. It means we should move this one to the right. I'm going to copy this, put this here. This is the meaning. It has shifted what? To the right now by 2. If you convert these guys to decimal in 2 decimal place, if I run this, I have 12. Good. So now let me go here again and do it. If I do this one now, you see, I have 12. Therefore, if I have, for instance, Q is equals to 48, assume this was the value of this guy, and I say, okay, Q, shift to the right by 2. Okay? But after you shift it, whatever you have, assign it back to Q. Remember what we are saying? The old value, which is 48, right shift it by 2. What we did here, we had 12. Once you have the 12, assign the 12 back to Q. If you check Q here now, you find that Q, if we run this, if you check the value of Q now, currently, Q is 48. If we do this now, 12 will be assigned to Q. If I check Q now, you see I have 12. Okay? What if I give you something like this now? Say 4, right shift equals to by 1. Let's first of all get 4. What is 4? 100. That's 100. Okay? 100 is 100. Move it to the right by 1. That is the meaning of this. If you check this one now, 10, that is 2. This will be the what? The decimal value. If you want to convert it using Python, you can simply say integer, then you do something like this. You say 2. If you run this guy, you have what? 2, which I told you just now, 2. So now let's come back to this place now to say, I want you to do something for me. I will first of all put k equals to 4. Then I will do something like this, say k, shift the value by 1 towards the right, assign the value, the result, back to k. If I run this, I check k now, k will definitely be 2. You see 2. This is what? Left shift and right shift. We are still using what? Assignment. Whatever result you have at the end of the day, assign it to what? To the variable on the left hand side. Hope this whole topic is understood. Thank you for viewing. Let's look at the bitwise operators first. Then we'll be able to look at the bitwise with the assignment operator. These are the bitwise. The add, the or, and the XOR. Let me explain. When we say bitwise means we are dealing with bits. If I say, for instance, 2 and 3, it means the binary of 2 and the binary of 3. What is add operator? In binary, 1 is true, 0 is false. Add means if we have 1 and 1, we see we have what? Another 1. If you have 0 and 1, this is not allowed. We have 0. If we have 1 and 0, this is not allowed. We have 0. It must be true for both sides before the result can be true. Okay? Let's use this website, Purple Math. This is binary of 3. This is binary of 2. Means this and this will give you 0. This and this will give you 1. Let's convert this one back to what? Decimal. 1 and 0. If we check here now, 1 and 0 is 2. That means if you do this and this, you're going to have 2. Let's run this. We have 2. Okay? Now assume I say, for instance, v is equals to 10. Okay? Or let me say v is equals to 2. I tell the system that v add equals to 3. This means 2 that is here, do the add calculation of bitwise with 3. Whatever that is the result, assign it to v. And we have actually just done that here. And the result is 2. It means now, if we do this again, v will remain 2. Okay, if we run this now, what is v? You see, v remains 2. Hope you understand this. Now let's look at the OR bitwise. Okay, let's use 2 values. Let's this time use 5 and what? 6. That is. This time we are talking about OR. OR is represented by pipe, straight line. That is OR. It means if we have true for both sides, that is 1 and 1, the result will be 1. If we have 0 and 1, the result will be 1. If we have 1 and 0, the result will be 1. If we have 0, 0, the result will be 0. So for this type of T, this is 1, this is 1, this is 1. It means 1, 1, 1. That is, if you do 5 and 6, we are going to have 7. Let's see. 5 or 6 gives us 7. You see? Now let's do something. If I say R is equals to 5, I say R or equals to 6. This means this value of R, do OR with 6 using their bit value or the binary value. Whatever result you have, assign it to R. It means if you do this, you are going to have 7 because we have actually done that here. This operator simply means put 5 here, do 5 OR with 6. Whatever you have, like 7, assign it to R. If we run this now, we say what is R now? You see, it's 7. Okay? Now let's look at exclusive OR. Exclusive OR. This is what we use to represent exclusive OR. Let's go back to this place. Let's pick a few numbers like 8 and 9. If you look at this, if you want to do the exclusive OR simply means if 1 is here and 0 is on the other side, you're going to have 1. If 0 is here, 1 is on the other side, you're going to have 1. If 1 is here, 1 is here, is 0. If 0 is here, 0 is here, is 0. What is that? It must be opposite. These are opposite before you can be 1. These are opposite before you can be 1. If they are the same on both sides, is 0. That's what? Exclusive OR. That is, these are exclusive OR now. They are all what? Exclusive OR. Remember the normal OR, if 1 is here, 1 is here, is allowed. But here, we don't want that. If you want to do this, for instance, you're going to have, here will be 1 definitely. Here is 0, 0, 0. So have 0, 0, 1. If you check here, what is 0, 0, 1? 0, 0, 1 definitely is same thing as 1. Okay, that is 1. If we run this, for instance, we say, okay, we know we use 8 and 9, right? 8 and 9. Let's do something. It's okay, for instance, T is equals to 8. Okay, we run. We say T exclusive OR equals to 9. It means the value of T, do exclusive OR with 9, put the result back to T. Currently, if I check what is T, the system will tell me that T is 8. If I do this, it means 1 will be assigned to T. If I run this now, check what is T now, say T is 1. You understand? These are all bitwise. Hope this understood. Thank you for viewing. Just now we saw greater than, less than. What if you want to compare two things together? For instance, I have A. Let's see what is A again. If I run this, it says 10. What is B? Say B is 10 too. What is C? It says C is 5. Now I want to say, okay, is A equal to B? We know they are equal, right? Okay. And B less than, or let me say C less than B. C less than B. I can compare these two. I know this is true. I know this is true. For AND, which is logical operator, the left-hand side and the right-hand side must be true before you can have a final true for all. Let's run this. See? Because this is true and this is true, it say what? They are true. Another way you can express this, you can put this one inside curve bracket. You also put this one inside curve bracket. Is this safe? It's true. Now, let's check again. A and B, they are equal. Let me say, is A not equals to B and C less than B? We know this is true, but this is not true. Because one of them is not true, everything will be false. Okay? This is called what? Logical operator. Another logical operator is OR. OR is a logical operator. That is to say, return true if just one is true. Return true if just one is true. I put OR here now. This is false, I know. This is true. OR is saying one side must be true before I will say the final is true. I can also do something like this. Is B greater than C or A greater than B? This is true. This is not true because of OR. But if this was AND, if this is AND, it will be false. Because for AND, both sides must be true. Finally, let's look at NOT. NOT means reversing what we are looking at. For instance, this is false, right? Let me reverse everything. If I come here now, I drop this. Look at what will happen. It says true. When you want to reverse the final result, put not, the opposite of what you have as the final result. This is true. Let me copy this. I will put not here to reverse the result. You see, it's not false. Something that was true before is not false. Let's put this false. This is false, right? You can see it's false. Let's reverse it, the opposite. So it depends on your style. You can test your variables like this. It's not true. All this is understood. Thank you for viewing. You are doing something and you want to compare two variables. Know that you are covered. Python has operators it uses for comparison. The first you are going to consider is this. This means equal in Python. In mathematics, only one is equal, but in Python, you need two to what? To check if two variables are equal. For instance, if I have A is equals to 10, I have B is equals to 10. Then I can ask Python if these two are equal by saying, is A and B equal? Say it's true. If I have C is equals to 5, I ask Python, is B equals to C? Say false. That is how to compare. But I can also ask Python, not equal. That is, not equal. With the help of these, you negate the inequality. Is A not equal to C? It says true, they are not equal. If I do the same thing now, I say what? Is B not equals to A? It says false because B and A, they are equal. So if you test something like this, it will tell you that what? It is false. Okay? Where would you need this, for instance? I can say if A is equals to B, print nice. We are going to see all this later. Just want to show you. But if I put C here now, because they are not equal, this will not be printed. You see, nothing was printed. Okay? What you want to check for greater than? That is greater than. Is A greater than C? That is the meaning of this. If I run this now, it says true. Is C less than A? Is also true. See, we have tested two now. The two are greater than and what? Less than. These are what? Comparison operators. What if you want to check for less than or equal to? That is to say, are they equal or is it less than? Definitely you can do something like that. Let's say A is equals to or less than B. You will see it's true because although this is not true, this is true. Less than or equal to. One should be correct for you to see true. What if I ask the system, is C less than or equals to B? You see? Next, I can also ask on the other way around, C greater than or equal to, let's say B. It's false because C is actually what? Less than B. It's not greater than, it's not equal to. But if I copy this, I put it here, I put A here now. Is A greater than or equals to B? One of them should be true because A and B are equal. So it's true. These are all comparison what? Operators. Next, we are going to look at logical operators. Hope this is understood. Thank you for viewing. Now let's look at Python identity operator. What is that? Look at this. If I say A is equals to 14, for instance, I say G is equals to 12. I say what is the address of A? That is ID. Okay? I also say what is the address of G? If you want to find address, use ID. Then you put the variable. You can see that they are in different address. Here, they are not in the same location. But if I say D is equals to 14, for instance, I also say T is equals to 12. Let's see the address of T. I want you to notice something. D is what? 14. Look at the address. Let me copy the address. D is what? D is 14. A is also 14. Look at the address of A. Let me put the address of D here. Are they not the same? They are the same. Because they have the same value. What is going on here? Look at what is going on here. What Python does is that whenever you put any value, not the variable, now value, it will create address in the memory, like the 14 scenario, it will simply put 40 here. Now you say A is equal to 40. It to simply point this to the location. A is pointing to location. In case you want to get 14, you can use me to locate 14. Now you are saying here again that D is 14. What it will simply do, it will not create another address for another 14. The same 14 you have already in the memory, Python will search the entire memory to see if there is 14 already in the memory. If there is one, it will simply put here now D are pointing towards this. So this and this now, we say what? They are pointing to the same location in the memory. And the memory address, as you can see, is this address. That's why two of them have the same address. In this type of scenario, we can easily say A is D because two of them are the same. A is what? D. We can say A is D. See what will happen? Say it's true because they are pointing to the same location. G is 12, T is 12. That means both of them are still what? The same. G is T. Identity. They are the same. But we know that A is not G. A is G, for instance. They are not. It's false because they are not in the same location. They have different values. But if I say A is not G, definitely I am right. What this is testing is my statement, the statement we are making, because each line of code is a statement. A is not G. A is not G. Of course, A is not G. That's why it is true. So these two, is and is not, we call them what? Identity operators. Hope you understand this. Thank you for viewing. Python membership operators. What are they? Although we have not done list, we are going to do it very soon. If I have 4 here, all these are what? Wrapped in square brackets. This is a list. I can assign this list to what? A variable. Let's say the variable is n. If I run this, if I put n here now, this is n. If I check the type of object, it's a what? It's a list. Now, I can ask the system for in n. Let's run this. It says true because 4 is inside n. What if I say s is equals to 8? I can also ask the system s in n. Said it's true. But if I say p in n and there is nothing like p, it doesn't even know the meaning of p. So let's assign something to p. Let's say p equals to -9. Therefore, p in n. Let's check again. It's false. There's nothing like that. This is used to check membership. Is this value or is this object member of this object? You use what? In to check if a particular object is a member of another object. The opposite of this, you agree with me, is what? Is not. So like this one will be true if I put not here. P not in n, which is true. But this is true because actually s is a member of n. But if I want to say it's no longer a member, that means I am lying. See, it's false. You are lying. So in and not in are two operators we call membership operators. Hope this is understood. Thank you for viewing. Now let's look at Python comments. If there is anything you want to comment in Python, you simply use hash. So you can now write this is a program. So I can still go ahead. I do what I want to do by say, for instance, print 2 plus 3. If I enter, I have 5. As you can see, this did not affect this because I put the hash. If I remove this hash now, I run this again, you see, it's looking at this as part of the program. So because you feel like commenting this out, simply use what? This. Then if you run, this would affect your program. So whenever you want to comment, use what? The hash. What if you want to comment multiple lines? Multiple lines. For instance, I say this is Python. I love Python programming language. Something like this. You can see this is a line, this is another line. So I can use hash. That is okay, for instance. You can't do like this. You must still put what? Your hash. You can do this for what? Multiple lines. Say, I can still come here and I say print 9 plus 0. So this never affect this program. Another way of doing this is by using the double quote 3 times. The beginning 3, end 3. So I can copy anything I want to put here now by saying this is a lovely whatever. Let me just continue. Wherever I want to do multiple line, then I will now come down here now to see do what I want to do in program. Say, okay, I want to print, for instance, hello world. See, when I run this one now, it's only this hello world that was returned. The output is just this. This was what? Neglected because of this what? Double quote in 3 places. So either you use this method or you simply go after each of them. I use what? The hash, each of the lines. I can still do something like this. So you now know just one line, use hash. Multiple lines, you can still use hash for each line, which is tedious. Or you simply use what? This double quote 3 times. Hope this is understood. Thank you for viewing.
It's break time. Do you like this video? Don't forget to subscribe to get new videos. Share this video to open new premium videos and ebooks. We'll be a star freelancer.
In our daily life, we are used to numbers and text. These are data types in our daily life. Either I want to put values in figures, or you want to express them in form of sentence, phrase, or clause. These are what? Data type. The interpreter needs to know the type of data that is coming in. But Python interpreter is so intelligent that without telling it the type of data, it knows the type of data that you are typing in. What are the type of data in Python? We have various type of data types in Python. Other than numeric, we have this like integer. When we say integer, we mean numbers without decimal, like 2, 4, 7, 8, and so on and so forth. We also have what we call float in Python. This is another data type. Anything with decimal like 3.4, 0.789, anything that has decimal is called what? Float. This one is called what? The numeric types. We also have complex numbers. That is the real side and the imaginary side. Then you put J to show that this is imaginary. All these types are what? The numeric type of data. So we also have what? This as what? We call it what? The text type. Okay? Text type is just what? String. In full, you write it like this. Okay? We also have what we call what? The Boolean type. The Boolean type, those are the bool. That is to say, the true or false. You can see this is capital letter. It's on purpose because Python recognizes the capital letter T, true, as true, and this capital letter F before this as false. If you put small letter, it will not recognize that. All these types, the numeric types, the text type, and the Boolean type, all these are called the primitive data type. Primitive data type. What you should now know is that if you want to have the non-primitive data type, from this primitive type, you create what? The non-primitive data type. As I said, the text type. We also have what? The integers, floats, and complex. I also told you about what? The bool. All these comprise what? The primitive data type. Then we have other type which among these are what? Non-primitive. We have the sequence type such as list, tuple, range. You are going to see all of them. We have the dictionaries, that is the mapping type. We have the set and the fuzzy set, that is other set type. We also have the binary type, which are the byte array, and memory view. All this will be treated in details. Among these, I said these are what? The primitive type. The non-primitive types are this, the dictionary, list, tuple, a set. All these are what? The non-primitive type. Okay? all of them will be treated. The non-primitive and the primitive type will all be treated in details. But before we treat them in details, each of them, if you want to check the type of data in a memory or in a memory location, what you need to do, assume I say s is equals to, for instance, 20. Python interpreter knows the type of data you are bringing in. If I say this is 20, if I say what type of data is this, how do I put that? I say type. This is to say what type of data is at x. If I run this now, I say what is integer. What if I say y is equals to 2.3? Let me say what type of data is y. Say what? It is a float. See what I was saying? It is what? A float. Because of the decimal is solved. What if I say z is equals to 1 plus 2j? I run this. Remember, this is complex, right? This is complex. For the type, what type of data is this? Say what? This is a what? Complex data. Okay. What if I say s is equals to my friend is good? This is a test, right? In Python, what type of data is this? I say type s is equals to what? String. You see? Now, for the other ones, like in the non-primitive type, if I say var is equals to what type of data? If I run this, I say type var. If I run this now, it says a list. How does it know it's a list? It saw this square bracket. With this square bracket, Python knows that this is what? A list. I just want to change the name to 2. Then I will remove this. I put a curve bracket here, a curve bracket. Python will give you a different type now. If I say, what type of data is this? var2. Why am I doing this? I want to let you know that Python knows them without telling it the type of data. Say it's a tuple. See? What if I come back again here? See, this one now is 3. I don't want to use a curve bracket again. I want to use what? A curly bracket. Now, Mr. Man, what type of data is this? It's a what? var3. Say it's a set. Okay, I still want to use this now, but this time I want to include something else here. Let me say I put here 4. Here I'm going to put 1 column, 2 column. That is key value pair. Don't worry yourself about this. We are going to explain this in detail. If I run this, I say, what type of data is this? It's telling me what? This is what? A dictionary. Then if I say, for instance, t is equals to this. I mean equal to. Okay? What type of data is this? T. Say what? A bool. Short for boolean. The same thing with what? False. If I say f, okay, let me not put f so that you will not think that because it's false, I'm using f. No. So if I say false, say what type of data is this? Type, you agree with me, it will definitely say what? It's a bool. But remember, if I say d2, for instance, is equals to, this is not false. Remember, Python is case sensitive. You see, when I type it, it's not showing like this. But if I put F here now, Python recognizes that this is what? False now. Remember I said, first letter must be capital. What if I've done something like this? Say false. See, it's not the same thing. They are different. Okay, at this time, we are going straight to the next part of this class. Hope this is understood. Thank you for viewing. Hi, in this class, I want to look at list. So what is the meaning of list? List is a collection of arbitrary objects. Collection. Remember, I said collection. Remember, everything also in Python are objects. Objects like integers, objects like floats, objects like boolean, and so on and so forth. If you want to collect them together, you are not talking about what list. You go to market, you want to buy things. You got to sort. You get meat. You get oil. You get rice. And you want to cook. This is the list of to buy. The things I want to buy. So this is list. So in Python, if you want list, you can do list of integers, list of strings, list of booleans such as true or false, and so on and so forth. You can able do a mix of these things together. How do you define a list in Python? If you want to define a list in Python, you use the square bracket. I put whatever you want to put here, then you separate them with what? A comma. Let's look at that. Look at this. This first one is what? The to-do list. Okay? Read, dance, run, sleep. You see, I want to define this list and I'm assigning the list to a variable. And this is the variable I choose. To tell the system that this is a list, I start with what? A square bracket open and close square bracket. If I run this, the system accepts without any error. The next one I say what? Animal list. Goat, cow, dog, pig, cat. You can see they are all strings, altogether strings. Let me run this one too. No issue. Number list as well. 1, 2, 3, 4, 5, 6900, 102. These are integers. The list of integers, list of numbers. Let me run this one also. Great. Now let me check what is in to do. If I run this, it gives me what? This. Let me check this. If I run this, it's giving me what? All the lists imputed. So the collection of all these objects is called what? List. The same thing with this. These are all object integer. The collection of all these objects is called what? List. Okay? Can list contain arbitrary object? Of course. If you are going to the market to buy something, nobody will force you or want to buy. You get there, you buy what you want to buy. List gives you the freedom to put anything you want to put. For instance, here we have same types. They are all strings. Here strings. Here they are what? Integer. That doesn't mean that you can't mix them together. You can put any type you want to put as long as it is an object in Python. And in Python, everything is what? Treated as what? Object. So it's arbitrary because you can choose to put what you want to put in a list. Let's see. If I come here, I say this is miss. I put one, the integer, 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 integer. This is float. This is float. I can put a string, put, then let's assume I want to put a boolean. What do you want us to put again? What about data type like integer? I can put, say int, string, I can put it. These are all objects what? In Python, because Python treats everything as what? Objects. Whatever interests you, just throw it in. Okay? Now, let's run this. No error. Let me see miss. See? There's no error. And if I check type, a list, you see? List accept arbitrary object. Whatever that comes to your mind. As long as it is a Python object, you can include it in your list. As you can see, this is a list that contains several arbitrary objects. Here we have a list inside a list. Here we have what? A set. Here is a float. Here is a tuple. Here is a dictionary. Here are booleans. Here is a string. All these are thrown into what? This list. And it is allowed. Let's check. So if we check for list now, you find out what? It all accepts without what? Error. So as long as what you are putting in is an object in Python, because Python treats everything as object, it is allowed. So list can contain any arbitrary what? Objects. Hope this is understood. Thank you for viewing. How many number of objects can a list contain? Here, we're going to make it empty. Here, we're going to put as many as we want. As many as you want. Here, we just duplicate as many of these as possible. You can see, it can be up to trillions. It doesn't matter. So list can what take as many input as you want to take. So let's run this now. No error. Let's run this. No error. So let's put S here. What is it saying? See? Empty list. Let's put B here. What is it say? See? Everything came up the way it was what? Imputed. This to let you know what? As many as input you want to put into this place or items you want to put in the list is what? Acceptable. If you like, you can put even a single item in the list. For instance, if I say y is equals to, let me say hello. This is single. Let me check y. It's okay. It's giving me this. What type are you? List. If you have a situation like this, when only one item is in the list, it is called what? A singleton. Okay? Hope you understand what we've treated. The purpose is to see if a list can contain no item, if it can contain many items, as many as you want, in millions, in billions, in trillions, or just one item, which is what? Singleton. Hope this is understood. Thank you for viewing. A list ordered or unordered. The first thing you need to know, what is the meaning of ordered or unordered? When we say something is ordered, we mean it comes out the way you what? Impute it. Can see? If we put S here now, you see that it's exactly the way I type it. That's the way it comes out. This is what we mean by what? Ordered. To understand this, let's look at set. Set is defined where you use the curly bracket. I'm going to copy it exactly the same thing here. I will put it exactly here. Let's run. What made this one set is because of this. What made this one list is because of this. Okay? Let's check S now. See, when I drop S now, you see, this was the way it was entered. It's coming out like this. 0 that was here is not first. 4 is not here. 6 is not here. It even removed the duplicate. This one now is not what? Ordered. This is what? Unordered. Because it came out differently, or it arranged it for me. When it arranged it for you, we mean what? It is what? Unordered. When it comes out the way you put it and it comes out like that, it is what? Ordered. So list is ordered. As you can see, set is not what? Ordered. It's on what? Unordered. Hope you understand this. Let's try another one. If I say R equals to, let's say A. If I put this here, if I run R, it was the way I enter it. That is the way it comes out. What if I decide to create another one? Say U equals to this, but this time it's going to be what? A set. You see, it was entered like this. So let's run this. Let's check U now. You see, it arranged it for me. List is ordered, set is not ordered. In this class, we learned that list is what? Ordered, not what? Unordered. Thank you for viewing. Hi. Look at this. How do you access the elements of a list? This is a list. These are what? Its elements. Assume I want to access this string. What do? You use what? Indices. Index of a list. From left to right, this is position 0, position 1, 2, 3, 4, 5. From right to left, you start with -1, -2, -3, -6. You can use either of them. So let's start. You say to do. You put your square bracket. If I want to access this, this is in position 1. I just put 1 here. It gives me this. If I want to access this, this is 0, 1, 2, 3. I put 3 here. Access sync. What if I want to use the negative number? That means I want to start from right to left. If I want to access this, this is -1. See, if I want to access this is -3. What it means that if this is -3, from right to left, But from left to right is 0, 1, 2, 3. Okay? 0, 1, 2, 3. So that means if I also put 3 here, I should be able to have the same thing. It means that this is this. I'm testing it now with this. I'm testing to see what is on the left here is equals to what is what on the right side. If I run this, I have true. Another way to test, I can use the double equal to, then I have this true. You see? So to access elements of a list, you use either the negative list index or the positive. Either way is okay. Let's look at slash C using positive and negative indices. Remember, the word indices is same as this. It's the same thing. These two words, they are the same. So don't be confused. We are still talking about accessing the elements of what? Of a list. What if you want to get this group? How do you do that? That's when slash C comes in. Let me explain to you how it works. For instance, if I want to get this to this, I will simply say to do, I will put 1, then I put 4 here. I will tell you why. The rule says you start with what is here, count, but when you get to this place, don't reach this place. What we are saying, you start with 1, 2, 3, don't touch 4. So I call this last one touch not. That is what Mr. Touch Not. Don't touch me. Whenever you are using slash C, that is, you want to take a range of elements from a list, you start with the first one, whatever is here, whatever that is here, you start with it, but don't get to what is here. Whatever that is before this, that's where you stop. What I'm doing simply is, I'm saying you start from here. Let me count everything. I'm saying start from here, continue, don't reach 4. So don't come to 4. You have dance, run, sing. Let's run. You see? What if you want to get from this to this? You already know. You start from 0. Then this is 1. If I put 1, it means you can't get to this place. I will simply put what? 2. Don't come to 2, but you can come to this. If I run this, I have this. What if I want to try the negative side? The negative side, this is -1. This is -2. This is -3. I want to use the negative side to get all this. Where do I want to start from? I want to start from this, get to this place. Now, let's label them. That is -1, -2, -3, -4, -5, -6. Okay, let's start from it to run. So because I'm starting from here, I will say, okay, I will start from -4, but I don't want to get to sleep. So I will put, I don't want to get to -1. That means -4 to -2. But don't touch -1. It means this is what I will get from run to it. Let's see, -4 to -1. Let's run. See, run to it. Run to it. Okay, let's try another one. What if I want to use slash C to get only this? I know I can put 0, 1, 2. I can use 2. If I put 2 here, I know I will have run. But if I still want to have run, use this slash, same. All I have to do now is to put 3 here, meaning 0, 1, 2. Start from 2, but don't get to 3. That means 2, 2. That means this is the place it will end. See? But if I put 2 here now, what I'm telling the system is, start from 2, don't get to 2. Then look at this. Nothing will be there. Actually, it picked run before when it started. It came to this place. I found out it's the same 2. You are telling me not to touch 2. not to touch position 2. So I will discount this instruction. This is the most recent what? Instruction. That means you don't want me to take anything. I will drop it, give you what? An empty list. We have succeeded in getting this using this. If we want to go to the opposite direction, how can we still achieve the same thing if we follow this other side? That means we start with run. Let me first of all copy this, paste here. Let's look at the position of run. 0, 1, 2. Starting with 2. Then to eat, 3, 4. We need 4, but it must not reach 5. This means don't reach 5. Let's run this. We have the same thing. What if you want to go without the beginning index or the end index? How do I mean? This is a list. Now, I want to start from Python without putting any indents at the beginning of the slash C. That is, I do something like this. Let me just put 2 here. And you agree with me that this is 0, 1, 2, 3, 4, 5, 6. If I don't put anything here, it means it should start from where? From the beginning. I get to this position. Remember, once you see a number here, you don't get to that number. It means it's going to take Python and what? Java. Let's see. You see? Let me copy this now, paste here. What if I put something like 2 here? I don't want to put anything here. This one simply means start from position 2 to the end. Therefore, this means beginning. This one means end. What I mean is, where there is nothing here, it means what? Start from beginning. Where there is nothing here, it means what? Get to the end. So we start from position 2. So this is 0, 1, 2. From C++ to the end. See? From C++ to the end. You can easily predict what will happen here if I don't put anything here. This one means start from beginning and get to the end. Where there is nothing at both sides of what? Of this. If I enter, everything is returned. That is the meaning of this. So note, where there is nothing here before the colon, it means start from beginning. Where there is nothing here after the colon, it means get to the end. Now let's do what trick. If I give you something like this, I say, this one means start from 2 to the end. This one means start from beginning to position 1. Remember, we don't get to the end. So this one we still print the same thing. We still print what this one we print. Everything was printed, but I will explain why it is like this. Let's just check it. This is here. Okay. And Java. Why was it not exactly the same? Because if you look at it, we said what? Start from position 2 to the end. So it picks all these to the end. You can see all these to reddish. For this guy, it says start from beginning, get to where? To 1. Don't get to 2. This is the beginning 0. This is 1. This is 2. Never come to 2. Remember that? Never reach here. It means these 2 will be taken. But if you want it to come out the way this result comes out, you have to reverse it. Reverse this. It means it will start from beginning now till it gets here. This one take off from there, from position 2, then to the end, which is not here. If we run this now, we have what? Similar result. Oh, this is well understood. So we can conclude that this is the same thing as what? As skills itself. Say it's true, because if you put skills here, you have this, right? If you put this here, you have the same thing, right? But know that this, okay, is not equals to this. When I put this here, if I change it, they are no longer equal. This is not mathematics. It's false. See, they are not equal. Why? Because is trying to compare. I have this. If I run this, I have this. Though they all came out, but when it was comparing, it found that C++ is here, Python is here, Neo4j is here, Java is here. See? They are not equal. They are equal only when you found out it is exactly the same thing like this. Okay? Hope this is not confusing you. We know equal result came out, equal output came out, but in comparing, they are not. This is just by the way, I'm just trying to show you. Let me show you another thing. What is that? If I take this for instance, let me say this 2, I drop, I have this. And if I want to still get the same result now, what should I do? Without using this one, I have to find what? How many number are there? If you look at this place, 1, that's 0, 1, 2, 3, 4, 5, 6. It means if I put 7 here, remember, because I want this position to still come out, I have to extend it by 1. If I put 7 here, I will still have the same thing here. Are they not the same? They are the same, right? See, they are the same, right? What can I do to also have the same result? If I copy this, I paste here, I can still say, okay, what is the length of this 1, 2, 3, 4, 5, 6, 7, right? Another thing you can do is use the length function, which is what? The length of skills. If you do the same thing, you have the same result. Why? Because this one will return the length of the whole thing. Okay? You can do something like this too to still have the same result. Because we are using 3 different methods now. This, manually putting it, or using what? Your link function. This one is better because sometimes you can have millions of items in a list. So using this is better than what? Counting it manually. Hope this is well understood. Thank you for viewing. Here, we want to use stride to access the element of this list. What is stride? If you want to access this, then you jump, access this. You jump, access this. And so on and so forth. What you are doing, you are moving by stride. You are jumping. It could be that you are interested to pick the first one, you leave 2, pick the next one, you leave 2, pick the next one, you leave 2, pick the next one. This is stride. How do we do this? This is done by first of all telling the system where you want to start from. I want to start from 0 there to the end. This is the end. 2 things I can do, I can count manually, or I will just simply say learn list. This one simply means everything, because I know this one will return the length of this for me, and the length will be the number that will be here, whatever that length is. Okay, then I can come here now to tell the system the stride that I want. So if I want every other one, that means it's the same thing that it will give to us. If I want every other 2, that means 1 will be jumped. Okay, you see, pick this one. I start from 0. Then the next one you should pick now, you jump this as 1, 2, 1, 2, 1, 2, 1, 2, till you get to this place. If you want to go by 3, 3, you move like this. You pick the first one, 1, 2, 3. You pick this. 1, 2, 3. You pick this. 1, 2, 3. You pick this. You get it? This is called what? Stride. If I wanted to count it, I could have done 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So I can put 11 here, which is the same thing. Okay? If I wanted to move by, let's say by 4, every other 4, I pick the first one, 1, 2, 3, then 4. 1, 2, 3, then 4. This one is not up to. That's why we have this. This is refers to what? Stride. You are accessing the element of this list with the method of what? Stride. It's like you are jumping. Hope this is clear. Thank you for viewing. Okay. Now we want to learn how to reverse a list. Reversing what? A list. This list starts with what? A. We want it to start with J, followed by Z, followed by M, then go to what? A. We want to reverse it. How do you do that? You take the name of the list, you put 2 columns, they say -1. This is how to what? Reverse a list. Okay? You see? So whenever you want to reverse a list, simply put what? -1 after 2 columns. You need to understand what is going on behind the scene. We say list, then open bracket. If you put a column here, you make here empty, and you make it empty, it means start from beginning to the end. That means if I close it here now, start from beginning to the end. We agree that if you put second column, whatever you are putting here now, after the second column, you are defining the stride. If you put 1 here, that means you are asking the system to start from beginning to the end. The stride should be 1. That means pick this, pick this, pick this, pick this, and so on and so forth. If I make it 2, it means start from beginning to the end. The stride will be what? 2, 1, 2, 1, 2, 1, 2, and so on and so forth. I remember that if I say 2, 1, 4, whatever, it means behind the scene there's a plus here, mathematically. When I say 2 plus 1, it's 3, right? If I say -2 plus 1, which is equals to -1, right? Why did you say 2 plus 1 is equals to 3? Because there's invisible plus before this 2. But if it is minus, you must put it. The same thing goes with this. Here, there's invisible what? Plus sign. Though we are not writing it. If it is plus, there's no need to write it. But if it is negative, you must write it. Let me go back and show you something. What I'm saying is, if I put this here now, it means it's +1. It means I am asking it to go what? In the positive direction. See? Move positive direction. If I put negative here, it means go opposite direction. So if I put 2 here now, I am asking it to go opposite direction. Start from beginning to the end, but in opposite direction. This one is telling us what the direction. This one is telling us what the stride. That is, start from here to the end, but be jumping 1, 2, 1, then 2, 1, then 2, 1, then 2, till you get here. Again, I can say -4, meaning if I remove this from here now, it's positive direction. Start from A to the end, but go first stride. 1, 2, 3, 4. That's T. 1, 2, 3, 4. That's M. Cannot go again because this one is not up to 4. If I put minus here now, it means you should move in the opposite direction. From beginning to the end, opposite direction. Meaning, start from beginning, then go down, but in opposite direction by 4, 4. Meaning, you take J first, say count Z, that's 1, 2, 3, 4. Q. 1, 2, 3, 4. D. Okay, let's see. See? Q. J. The Q and D. Hope you understand how to reverse it now in opposite direction. And you can also move by the number of stride you want to move by. Either 1 stride, 2 stride, 3 stride, and so on and so forth. Hope this is understood. Thank you for viewing. I want to look at something. If I want to get this O value, I can simply assign this, then I will have this return. I can do the same thing for what? For a string. Before that, let me run this. Let me also write something like, let me say string equals to ABC. I run this. So what I'm saying is, if I want to have this whole result, all I need to do is to say this. I will just copy this, for instance. I paste here. It means start from beginning to the end. I have what? The same thing. The same thing, no difference. Then Let me also apply the same thing to a string. You see, I have what? The same thing. That is the work they do. They return what you are seeing here. But there is a difference. That difference is very important you understand it. The difference between when you apply this on a list and when you apply this on a string. What is the difference? For you to appreciate the difference, I will copy this again. I paste here, then I run again. If I want to know the address of this variable, where it's located, or the address of this object, all I need to do is to say ID, then I put the variable. See the address of this particular one. Look at it very well. Now let me also copy. Take this, I put here. Just this. If I run, remember I'm still having the same thing. I want to know the address of this. I want to know the address of this. Or let me remove this. I simply say, okay, I want to put this one like countries. If I do this, the result this one will generate will be a copy of this guy. If I run this now, you see, I have the same thing. But what I want you to know is that what this one I've done is copy this, I put them in a different address. It's putting them where? In a different location. So what you are seeing here now is not the same thing with what is here. Okay? How do I know? If I copy this now, it's okay. ID, what is the address of this new object? I have what? A different address from this. You will not appreciate this until I demonstrate this very one. That is this one. Let me go back and demonstrate this. If I put this here, I run this. I also copy this, I paste here as okay. Let's check this. We have this. Okay, now I want to check the address of this string. Only the string. I want to know the address. You see the address of the string? Let me see the address of this. Are they not the same address? You see? You can see that the address of this, okay, here, is what? Is this. Address of this is this. They are the same. It means this one is simply referring to where? Is simply referring to this one. It's just pointing to this guy. It's just showing you this guy. It's not doing anything new. But here, there's a big difference. What this guy is doing is copying this and putting it what? In a different address. Okay? That's why we are having two different addresses. This address is different from where? This address. Because when you apply this, on this, it will copy this and put in a different location. Okay? It just copy and put in a different location. If you do it second time now, for instance, if I do it 3 times, let me put this here. Let me say this one is S is equals to this. Let me apply it to X. Let me say Y is equals to this. Let me say Z is equals to this. If I check the addresses, they are all different. Because it's just copying and putting where? In different where? In different addresses. You see? All of them are in different what? Addresses. They are all different. So this guy, what he's doing is copying the original value and putting it what? In a different location. But if it was a string, I say, let me say H is equals to something like this. If I do something like this now, I run it. If I also do this, let's assume, okay, now, instead of doing this like, let me also assign this to D, assign to D, assign to R, assign to J. You will find that this one is assigning, if I check the value there, for instance, I say, what is in D? D is telling me that what is HJK. But what is the address of D? Is this right? What is the address of R? Same, right? What is the address of J? Same. That means if it's a string, HJK, that is here now, in this location, as a K, M is equals to this, for instance. If I'm going to do M, this guy is only pointing at this, irrespective of the number of times I apply this on this. But if I say N is equals to list 1, 2, 3, if I apply this on N, it will still give me the result, but this time it's a new result in a different what? Location. If the address of this one was, let's say, 247, this address will be what? Be 248. If I do it another time, again, it will still make a copy of what? Of the original. I put it what? In a different what? Address. But for string, it doesn't do that. It is just the same address. That means what you are doing, you are not copying, you are referring to what is already done. But what you do for list, you are just generating new object. You are creating new what? New object by making a copy of the what? Original. Hope this is understood. Thank you for viewing. Most of the operator are built-in function in Python are applicable to Python list. Like this list, for instance, I can test to see if, for instance, US is on this list. How do I do that? I will simply say USA in countries. That is to say, is this element in this country? Say yes, it's in that country. If I say UK in countries, you say false, it's not there. If I've said not in, it says true. Actually, UK is not in country list. Here too, you can do the opposite of not. Here you can do the opposite of in. You see? False. Because it is there. It is. You can do concatenation with list. For instance, equals to, say, Brazil. Let's say another one is Congo. So I can easily say, okay, I can do something like this, for instance. This plus these two. See? Combine everything together. I can do something like this to Ghana. You see? Added it. Poland and Ghana. You can do also replication. That's to say, I pick this now. I say multiply by 3. You see? What is it doing? It picks this list. When you finish India to Australia, it start again, another India to Australia, then another India to Australia. Let's try this. Country 2. Countries 2. Let's multiply by 2. See, you finish this, then this. You see? What if you want to apply something like the length of country 2? You can say only 2 were there, because if you check the original countries 2, it's only Brazil and what? Congo. Just 2 countries. You can also check the maximum of, say, let's say countries. It says USA. Among them, say US is the maximum. Why? Because it's looking at the first letter. This I, this C, this is the last. If you do minimum now, you have Australia. Do min, you see Australia. You can also do something like this by saying, okay, let's say 1 like string. You can do something like this direct without any need to put them what? In variables. I can also do something like this. Let me copy this now. I can find the length of this street. Says 5. 1, 2, 3, 4, 5. I can also find the minimum street. It's 1. I can also find the mass street. What if I want to reverse this? If I want to reverse it, for instance, remember, if you want to reverse, you do this, -1. See? Now, starting from 6 to 1, reversing this list. What, for instance, I want to get 2, direct. Remember before, we put this in a variable before we apply whatever I want to apply, but I want to apply that right now. For instance, S equals to this. If I want to get 4, I say 0, 1, 2. Put 2 here, right? But I can just take this one direct if I want. Then I apply the same 2 on it. I will still have the same thing. You can apply direct, or you assign them to a variable before you what? Do this. Either way. I also come here and say, okay, I want to get this to this. That means 0, 1, 2. I want to start from 2, then and 3. So we do like this. Start from 2, but don't get to 4. That is 4 at 3. If you even want to start from beginning, like I want to start from beginning to the end, but it should be by 2, and do like this. That means start from beginning to the end, because there's nothing here, there's nothing here. Then use 2 stride. That is 6 first, 1, 2, 1, 2. Hope you understand all this. Thank you for viewing. At least mutable. The next question you should ask again is, what is mutable? When we say something is mutable, with mean it can be changed. So the question says, are lists mutable? That is to say, can we change list? Was assigned? Can you change anything? The answer is, lists are mutable. Let's investigate this. If I say C is equals to this list, I enter. If I want to check the address of C, I will say IDC. This is address. The next thing I want to do now, I want to change this value of 4. Let me say to 3. I will do something like this. C location 1 is equals to 3. It means if I check C now, I will have the 4 change to what? 3. Let's see if this address is still the same. I will say ID C. As you can see, all these numbers, they are the same thing with these numbers. So what this simply means is, we have a variable, and a list was assigned to the variable. That is 2, 4, 7, 8. And this variable has what? This address here. Address is here 1, 4, 0, T what? 2, 0, right? Now I decided to change this value to what? I change it to 3. When I check the location I'm still dealing with, I found that the location is still the same thing, the same address. If this was an integer or a float, it wouldn't be like this. Remember, integer and float, they are not like list, because they are what? Not mutable. Once you assign a value to an address, it remains forever. You can change it to another value. Let me show you what I'm saying. Assume I say D, for instance, is, let me say D number or D num. That's the name of the variable. I said the value that will be here is, let's say 14. The num is equals to 14. Okay. Then if we find the address of this denom, this is the address 4 3 5 2 8 8. If I change this 14 to 13 to 10 to 1, whatever number, this address will change. Let me show you. The norm is now 20. If I check the address of the norm, the new address of the norm, I found out what? It's a new address different from this address. You see? So what happened now is the system removed the norm from here, okay, took it to another location, assigned 20 to it, say this is not the norm, with a new address of what? 4 3 5 T what? T 80, which is different from this address. So when you call the norm, you call the norm now, like I come to this place, I say, what is the norm? Say 20. This 20 that is shown to me is this 20, right? Not here again. So how can we now locate 14? 14 is still in the memory in this location, but you cannot locate it with this denom anymore. You cannot locate it with this variable anymore, because the variable is not attached to another value. But this one is still in the memory. Why? Because once you assign integer or float, which are not mutable. You can't change them again. That means immutable. You can't change them again. But for this guy, if I change this one and the address remains the same, because you can change them. If you can't change them, C will go to a different address. So how do you know? It's about the address. When you see that the address changes, it means that what? That is what? Immutable. But if you see the address remain the same, that means it's allowing you to change what is in that location. But for this one, it's not allowing you to change what is in this location. That's why it's going to a different place to assign the new value for this what variable. So if I come to this place again, let me try it again. If I come here and I say, okay, I want to change this one to 10. 0, 1, 2, 3. I want to change C3 to 10. If I put C now, I have this. If I check the address of C now, I found what? It still remains the same. See? Look at C. 1401870. The same thing with this. Let me just copy it and put somewhere here. See, are they not the same? They are still the same. It means you are still dealing with the same location. But if you change the value of this now, this denom, to denom now is now 100 or whatever number. If you change the address now, ID of denom, you find out what? It has also changed again. It's just changing. See? The previous address of the norm is this. Look at the new address now. 840. Here's 1284. That is the heading numbers. So therefore, this to let you know that what? Lists are mutable. But for integer, float, you can't change their value. What's assigned is forever assigned. Such is called what? Immutable. In conclusion again, lists are what? Mutable. Let's look at how to modify a list. This is a list. Want to modify it. As I want to put a single value, in place of 7, we put 10. Or let's say we put U. Because I see, I want to put U here. That's 0, 1, 2. So in place of 2, I want to put what? U. If I put C now, see, I'll be able to replace 7 with U. That is just what? For single value. You can be doing that again and again and again. Okay. What if I want to modify multiple values? How would I do that? Assume we have D is equals to. So now, I want to change a range. So I can say, okay, I want to change from here to here. That is from 0, 1, 2 to 3, 4. I can put a single value there or put more than one. For instance, let me put more than 1. So if I say D now, see, all the new value have been included in the location I wanted them. Now, let's try to replace this and this. That is from position 1. If I put it, I have these two from D. So if I say I want to replace this with, let me run this. Now let's check D now. You see, just these two values have been replaced with all these values. This is what? Expansion. What if I want to replace again from here to this place with just only one value? 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So that is 12 now. Because we must not get to this position. So let's see. Exactly. So here I want to replace this O value with, see, hello. For instance, let's run. If I put D now, you see, I shrink it now, reducing the size or the length of the string to just what? 3 instead of this that it was before. So this to let you know that what? You can either expand a list or you reduce the length. You can also put something here if you want. For instance, 0 position. I want to put for me for this. If I put D again, see, expanded. But this expansion now is bringing in a nested list, okay, which is different from this one. That was what? Just expansion. But this one is what? It's putting something in place of this only 4, which is position 0, replaced with what? All these values. The next thing you should ask me is, why is it like this? The reason is because you are not using slash C. This column this will give you a perfect result like this. Okay, if you want to have a continuity of the same list, use slash. You use a value, column, and a value to have a continuity like this. But if you want to have a nested list, a list inside list, don't use what? Slash. Simply do it like this by specify what? The location. Then you put what you want to put. So what I will do now, I will come here to replace this one again with just one value. Let me see now. D0 is equals to 9. If I put D now, so when are you going to ever have one value without what? This. You simply say in this first position, to locate it with slash C, you do something like this. 0 to dot get to 1. Then I will come here and I put same 9 to replace that. If I put D now, see, has removed that. This one means start from 0, dot get to 1. That is this position only. If I want to put something here now, continuity, I can address it as this. Put whatever you want to put. If I put D now, see, continuity. But if you want to do a nested list, I can choose this, for instance, a D. I just want position 2, but put something like this for me. If I do this as a D, see, nested. Hope this is understood. Thank you for viewing. Now let's look at how to modify a list using another list to prepend it or another list to append it. Let's first of all run this list. If I run that list now what I want to do is I want to take this list, okay, I add it to this list. I will say plus this list. Let's run. If I check to buy, if I run it now, I find that what? This has been what? Appended. I can also take this to buy, I put it here, then I can say plus equal to, then I put whatever I want to put after. Look at this. This will still be what? Appended. Remember here, I pick it, I put it straight using what? Plus. Instead of doing that, I already know that this is what? To buy, the original to buy. Before I added this, right? Good. So what I can do is, I can simply say, okay, I know what is to buy now. This is the new to buy. I will just pick the variable. I say plus equals to whatever I want to add. Still what? Appending. If I run this, I say, what is not to buy? Let's check to buy now. You see? Hope you are getting this. Okay, I want the new to buy to contain cap. The first on the list, I say cap, followed by class. You see what I'm doing? This is to buy, which is this. I want to add this too. All I want to do now, because I want this one to come before this, that's why I'm putting it here. I will say plus the whole to buy. You understand? This is what I want to add. This is what the old values, which are this. This object is not here. Whatever this one will give to me now will be added. I will have a new to buy. If I run this, I say what is a new to buy? We have all this. Still the same thing, just I want me to see everything. That's why it's not doing it what? Vertically. Okay? So you see that cap and glass are not before these old values. Okay? Again, remember, we started with to buy, the original. We append a list, use a plus. Okay? When we check, we found this. Then we say, okay, we want to also add this, but the same method, this and this are the same. But I want to use what? The shorthand method. Then this one I say, okay, I want to put something before. If you want to do this concatenation, it must be another list you are adding. You must add another list to a list. Let's check. If I say to buy is equals to buy plus, let's just say 35. Is this possible? Let's run it. It's giving us error. Okay, let me copy this again. I put here. If I want to add this, simply make sure what? It comes in the form of a list because this is a list. I am adding this, right? Let's run now. There's no more error because I am adding list to what? A list. If I run now, you see that what? 35 has come. Now let's try this. Okay? I see what will happen. Remember, this is not in the form of a list. If I add it to this now, see what will happen? It's giving us a what? An error. Can only concatenate list. not string to a list. But there's something else I can do. Assume I really want to add this food to it. I can trick the system by say put plus here. I do this. See what will happen now. No error. When I use shorthand, no error. But let's check the solution. It's not a desirable solution. See what it has done? It breaks it down, the food down. Let me make it shorter for you so you understand. S equals to this list, 12 and 34. See, S is not this plus this. You will see error now again. But if I want to deceive the system, not actually deceiving the system, I'm deceiving myself because the result will not be what? My desirable result. Let's add this now. Now, it says accept, but not what you want. If I run this now, you see, it's what? Breaking it one after the other. It is interpreting it differently. This is the danger of following this method.
It's break time. Do you like this video? Don't forget to subscribe to get new videos. Share this video to open new premium videos and ebooks. We'll be a star freelancer.
Now let's see how to delete value from a list. What I mean, if you want to delete something like this too, is simply specify the position. Okay, it gives me what? 4-7. If I want to delete it, I will just specify this. I put what? Empty list, meaning I want to remove these guys. If I put C now, see, remaining 2, 8, and 9. Look at this one. What if I want to delete this two, or I want to delete this one? I can simply say this, give the location. Then before this, I just say delete. If I put C again now, see, 2 has gone. Let me say Y equals to, okay, which other way can I use to delete all this one? Either use empty or del. We can use the method remove. What do you want to remove? I want to remove, let's say 6. From where? From Y. If I say Y now, 6 is gone. Okay, there's a third method, empty, second, del, third, remove. Now Y is 4, 8, 9, 10. What if I want to remove just the last one? Use what? The pump method. See, it's telling me what? 10 is removed. If I say Y now, see, 10 has been removed. If I use that again, Y dot pump, now to remove the last one again, which is what? 9. If I put Y again, see, and so on and so forth. What if I want to remove the first one and I want to specify, use a pop? I can do that. Or even the second value, that is position 1. See, it's removed. But if you don't specify anything here, it means you're going to remove the last one. Okay, if I put R now, I have only 2 remaining. Let me run R here now again so that R will come back to these values. Just want to remove only this. Simply say R dot pop. Okay, then if I say R now, it's gone. But you want to remove a specific value, like this one is the last value. I can easily say what? R dot pop. This, it will remove the water, but I can still specify that is the last one I want to remove. -1 is allowed. If I put it, see, if I say R now, what is remaining? Food is remaining. What if I come back here now? Let me just copy this, just drop it here. Let me call this value now V. Let's just increase the value of this to 10, 11. If, for instance, I want to remove this -1, -2, -3, I say V dot pop, remove -3. So V now is this without 9. Again, if I want to remove this last one, as I said, I can do tutti V dot pop. This will remove this value because it's not the last value. Or you can also put -1, which will still remove the last value. Okay, either way you are okay. If I drop this, I have what? V. 11 is gone. I can also say V dot remove. When you want to remove, as I said, you must specify the value, the actual value, which you want to remove. But if you want to use the pump, you specify the position of the value that you want to remove. Hope you understand this, but for remove, if you don't put anything here, you have what? Error. But if it was POP, you will not have error to remove the last value. Okay, if you put the position, like this is position 1, to remove that position, which is 4, you remove. But if you want to use value to remove, simply put remove. Then you put the actual value. If it's 8, for instance, I put 8 here. Remove. So if I say V now, hope this is very clear. To recap, because I want you to understand it very well. If you specify the range with your slash, assume it's C. Once you specify something N to M, just say equals to this. What you specify what will be deleted. That's one method. You can also say C dot remove. Then you specify the value that is it's 9, it's 10, it will be gone. But if you don't want to specify the value, but you just want to use the position, use something like C.pup. You specify the position. If you don't specify the position, you are indirectly telling the system to remove the last one. Another thing is you can also use what? Delete. Just say DEL. Then you give us what? The position. By say C, for instance, then you give us what? The location. Let's see 4, 5, 6, 7. Different method. Okay? Hope all these are clear. Thank you for viewing. Now let's see how to modify a list using the append method. So this is our to buy list. All we want to do now is to add something to this list. And you want to do that, you say to buy dot append, then you put what you want to include. Let's say for instance I want to put 1000. Let's make it different from these strings. If I check to buy again, I'm having 1000 appended at the end of what? Of this list. Mean append at the tail of what? Of the list. We can go further to say, okay, let's add a string. To buy again, car appended what? To this list. But what if we want to append another list inside this list? Remember, this is what? A string. This what? An integer added to this list. But now I want to add a list to this list. That is to say, to buy dot append, I want to put something like 30, 50. If we enter, see, this is a list appended. So if you want to access this now, remember it's occupying what position? All you have to do is to buy. The end means what? -1. That means these two. If we run this, we have what? 30 or 50. Hope you understand this. Two things. Either you put just one value, or you what? Put a list value. Or at the end of what? Of a list. Meaning what? Append at the end of a list. Hope you understand this. Thank you for viewing. Now let's use the extend method. To buy is what? Okay. Now if you want to extend a list, just the way you use plus to add another list to a list, that is the way this extend works. That is to say, I can say to buy dot extend. Then I will put what I want to put. If I want to put only one value, let's just say I want to put meat. Let's check to buy now. See? It's just what? Extending what? What was there before. What if I wanted to add more than one? Say I want to use. Let's add these ones. If I check to buy again, I have it extended. Just like what? The plus operator. How do I mean? If I say to buy, I can say plus equals to. Then I add one I want to add. Let's say I say 2000, 9000. It's okay. Let's see to buy now. If it's like that, yes. The same thing. As if you are using what? Extend. But what if you want to put a list inside this list? If you desire to do that, go back to the first method, which is append. Put the list you want to put. If I say to buy now, you see now, it has added what? Or appended what? A list to a list. The same thing with append. If you want to just put just one value, you can still do the same thing. Let's say 800, you can do the same thing. If I run this now, 800 is there now. Okay? Hope this is understood with extend. Again, if you want to extend an existing list, you can put more to it by using what? Extend method. Put what? The list of values. But in case you desire a nested list, all you have to do, go back to what? Append. Then you cannot put whatever you want to put. 600, 400. Then if you check again now, you find out what? This list has been nested to what? The existing list. Hope this is understood. Thank you for viewing. This, for instance, if I want to push this one to the right and make this place available for another item, like, let's say, shirt. How are you going to do this? You agree with me that extend does not have the power to do this. Append does not have the power to do this. Neither is the plus have the power to do this. It is difficult to use what we have learned to achieve something like this. What I mean, if you are given this and asked to achieve this, the only thing that can help you out is insert. How do you use insert? You simply do what? To by.insert. Then you tell us the position you want to add the value shirt. As you can see, it's at index of 1. That's 0, 1. I put the index, then I put the value or the object. If I run this, let's check to buy now. See, I have shirt before shoe. Remember, this is the index position, 0, 1. So I want to put this one to the right. Then put insert, a new object in that place. Remember in Python, everything is object. What do you want to put something at the end? I would want to replace this. If you want to replace it, you can use other method. But if you want to put something here without replacing it, simply say to buy, insert. What is the index position? -1, that is the end. Then I want to put something like what? Bike. I enter. So if I check to buy again, I have this. See? This has been pushed to the right. Then bike is not here. Hope this is understood, and you know the reason why we have insert. Because what insert can do, extend cannot do, append cannot do, even the concatenation cannot do. Hope this is understood. Thank you for viewing. Let's look at this index method. What does it do? We've agreed that each element of a list occupies what? A position. That is what? An index. For instance, this guy occupies position 0 or index 0. This one is index 1, index 2, index 3, index 4, index 5, index 6. So if you want to find the index of any of these items, you use this method. Assume I want to find the index of 7. I will simply say num list dot index 7. See, it says 4. Let's confirm it. This 0, 1, 2, 3, 4. So we use this method to locate what? Assume you want to get the index of 8. It says 5. Assume you want to get the index of a value that is not in a list. You have what? Error. And the error says 12 is not in list. Hope this is understood. Thank you for viewing. How to copy a list. This is a list. I want to copy it to a new variable. As we say new list. How do you copy this? Simply use this one. Dot copy. This method will what? Be applied on this list. I copy this list to what? To this new variable. If I say new list, we have the same thing. So which other way can you use to copy this list? There is another way you can use to copy this list to a new variable. Let me say new list 2 is equals to this. The meaning of this is from beginning to the end. Match it and assign it what? To this new variable. From beginning to the end of this, assign it to this what? New variable. If I enter, I say, okay, I want to know new list 2. Two options, this or use the method copy. Hope this is understood. Thank you for viewing. Let's look at list count. What is the use of this method? It is used to count the element of what? Of a list. For instance, you want to know the number of 3 in this list. You can use this. You want to know the number of 8. You can use this. You want to know the number of 4s in this list. Let's see. There I put what I want to count. How many? 2. That is 1, 2. What if I wanted to check for 7? Say 7 with just 1 in this list. What if I wanted to check for, let's say 8? Say 8 is 2. What if I wanted to check for 2? Say just 1. So whenever you want to count element in a list, how many times they appear, how many times a particular element appeared in a list, simply use what? The count method. Hope this is understood. Thank you for viewing. How to reverse a list using the reverse method and slash. If you want to make 2, the last, I label the first. You can achieve that by applying the reverse method on num. Let's see the reverse method, which is reverse. So the value in this num now is reversed by applying this on this what variable. If I check for it again, see what I have now. 11 is not at the beginning, followed by 8 till you get to 2. That's one method. Okay, now num is not this. What if I want to turn it back now? I can say apply this on it again. If I apply this, I write num now. Do not go back to the normal. See, it's not like this again. That's one method you can use. To use what? Slash. That is backward. If I look at num2 now, I will find out what? It is the reverse of what? Num. The reverse of this is not this. By applying this, which we have actually treated. And if you want to achieve the same thing, you can also apply what? Reverse method. Hope this is understood. Thank you for viewing. Let's look at sort as sorted. These are meant to what? To sort a list. Okay, this is a list. We want to sort it. What is that? That means we want to arrange this one in ascending or descending order. It depends on what you want to do. Because as you can see, this is correctly nowhere arranged. So let's see. If I say num dot sort, if I call num now, you find out what? It is nowhere arranged. You can see in what? Ascending order. Sort. If I want it to reverse, that is in descending order, I will put reverse true. By saying reverse true means I want it to be what? In descending order. What is the new value of nums now? See, it has reversed it for us now. Okay, let's get a new list. Okay, this is a new list. I want to use sorted now. This time I want to apply this what to a new variable. Okay, then I will say what? Sorted, call this old variable, then apply. If I check new list now, I found out what? It has been what? Sorted. As you can see, sorted. So the difference between this and this is sort is a method, while this what? It's a function. Okay? Function can stand alone. Then you put the variable you want to put. Why this one method must be applied what? On a variable. See? Dot the method. This one is what? A function. The next thing you should ask me now, what if we wanted to what? Also reverse this. Simply say comma, reverse equals to what? True. Watch what will happen here now. I will run this first. Then I will run this. If I check this now, you see, it's reverse in the opposite direction. That's what? In descending order. Remember again, this one sort and this sorted, they do the same thing. Just that one is a method, the other is a function. They both have this argument if you want to use. Hope this was understood. Thank you for viewing. Now you are ready to clear your list. How do you clear your list? There are two options you can use. Either you use del to delete the list. By say del, you call the list, then you say okay, from beginning to the end. Okay, this is the list from beginning to the end. Delete it. This is the first option. The second option is to use what? The clear method. The clear method is applied on the list. Assume this is a list. You apply the clear method on it by say dot clear. This one what? We clear all the objects in that list. Now let's apply the first option on this list. We run this. We say del. This is a list. Delete it from beginning to the end. Before we apply this, let's see what is in the list. Look at the list before we apply this. After we apply this now, let's check it again. Nothing in the list now. It's an empty list. Okay, what I will do again, I will go back here, copy, paste, to rerun the list again, to reassign the object. The list has come back again. Now let's apply the clear method by say list dot clear. If we apply this, now let's check again. Say list, what is available, nothing. These are the two ways you can use to clear the object of a list, to empty a list. What you should know is that this list still exists, but the only thing is that this is an empty list. It means if you want to add something to it, you can still add. For instance, I can say append 3. So if I check the list now, you see 3 is there. But what I did was I simply applied clear to remove what was there. So if I check again now, there's nothing there. It's not an empty list. So if you want to check the type to confirm that it's still a list, you can do like this. See, output, it is a list. That the type of object is a list. Hope this is understood. Thank you for viewing. If you are given this and asked to get this, what would you do? As you can see, this is a list. This is the input. This is the output. The output you are looking for is a reverse of this input. If you know how to reverse a list, this shouldn't be a problem, which we have already treated. Let's see. I will simply say list equals to, let me copy this, paste here, enter. There are two methods. I can say list dot reverse. So if I check list again, I get this. Now let me go back, copy this, and return it back to what it was. Another method you can use is to say list -1. You see, it has been reversed. All depends on you. Either you use this or you use this. Hope you understand this. Thank you for viewing. You are given this and asked to get this. What would you do? As you can see, this is a nested list. It is our input. So list equals to this. All you have to do is to locate the position of where you want to put this 99.99. To get that, we start for this first one 0, 1, 2, 3 to this place. So this is 3. So if I enter now, that means list 3 first. So when I get to 3, I will start counting from here now 0, 1, then 2. That is 2. Now I locate this position now. So it says I should what? Insert 99.99 after 3. You simply put insert, and that position is 0, 1, 2, 3, this place. In third position, that is the index, and the value is 99.99. I enter. If I check list again now, I have exactly the output. Hope you understand this. Thank you for viewing. You are given this and asked to get this. That is 99.99 and the end of this list. What would you do? Okay, we go straight to say list equals to this. What we are given. The next is we want to put 99.9 somewhere here after this. That means we need to locate this place. What is the index of this place? 0, 1, 2, then 3. 0, 1, 2, 3. Okay. So the first thing for this nested list is what we are looking for is in the what? This place. And it's at the end of this location. Append. Then I put what I want to append, which is this. Then I enter. If I check list again, I will find that what? 99.99 is not inserted in the exact location the question asks us to put it. Hope this is understood. Thank you for viewing. If given this and asked to get this, what would you do? The only difference between the two is this place. This 66, 77, 88 is asked to be what? Inserted immediately after G. Look at this. And we are asked to insert 66, 77, 88 immediately after this. And you can see the way it comes out. It's not nested inside here. It's an extension of this. It means that you have to use the extend method. Let's see. When we say list, then we locate this position. That is 0, 1, 2, 3. Okay? That's the first one, 3. If we get here, say 0, 1. That means 1. So we want to get here now, 0, 1, then 2. Dot extend. Before you even do this, we can just say given, call it any name, 66, 77, 88. Then I come back here now. I put what? Given. Here. I run this. So if I say list again now, you find out what? 66, 77, 88 has been added. Hope you understand this. Using extend to extend a list. Thank you for viewing. Given the list below, find the value of 45 in the list. And if it is present, replace it with 99. We have to use index to locate if 45 is in this list. So we copy this. Let's say index is equals to a list dot index 45. Now that we locate the position, because if I check index now, remember this index is not the same thing with this. This is a variable chosen by me. This is index method. Or what I will do, let me just replace this with I so that I will not be confused. I redo it now. Check I is 4. We don't need to check, but I'm just showing you that is 0, 1, 2, 3, 4. So what you need to do now is to say at least that we put I, which is whatever value that is here, now 4. We assign that location because this one will detect this location. Use this one to assign 99. Then we run it. If we say at least now, we find out what 99 is now here. Replace what? 45. Hope this is understood. Thank you for viewing. Find the length, the maximum value, the minimum value of the following list. If I pick this now, I put here. To find the length of this list, I will just say length a list. That's 9. That's to say 1, 2, 3, 4, 5, 6, 7, 8, 9. There's a number of elements in this list. So let's find the maximum value now. Then we put what? A list. We run. We have what? 90. What about the minimum? Mean a list. We have 10. So it means 9 is the length, 90 is the maximum value, 10 is the minimum value. Without using the extend method, turn the following input to output as shown. Okay, this is our input. So input now is this. We are asked add these ones without what? Using what? Extend. All you have to do, you simply say plus this list. How do you do that? You must bring these ones out in form of a list. Otherwise you have error. Then we add them. But if you wanted it to be output, assign it to variable output. You do like this. If you call output now, you have this. Hope you understand. I want it that is important. To add something to a list, it must come in the form of a list. That's why I put this one in square bracket. Hope this is understood. Thank you for viewing. Turn the following input to the output as shown below. That is to say, we should remove 6, 8, and 9. We have to locate them. This index of 1, index of 2, index of 3. How do you do this? We simply locate the range of index from 1 to 3, but we must not get to 4. How do you represent that? You say from 1 to 4, meaning start from 1, stop at 3, don't get to 4. We put input here. We assign this to empty list. Once we do this, if we check again, so from this answer we have this. So this is what the question is saying. If I run this again, I can also do something like this by say delete. Same. I can delete this. So we check again now. we have the same solution. Okay, either of them you are correct. Get this from this. What is this question up to? Let me say a list. I put this here. If you look at the pattern, 1000 first, we have 23, have 1, have 4. That means start from here. That is reverse. Okay, that's 1. Let's check the distance between 1000 and 23. We have 1000, 1, 2, 3, 4, 5. Okay. Let's check the next. 1, 2, 3, 4, 5. Okay. 1, 2, 3, 4, 5. Therefore, we're going to say a list that means start from 0 to the end, reverse it, go by 5, 5. That is the stride. You see? 1000, 23, 1, therefore. Hope you understand this. So if we check a list now, we have still the same thing. Okay? It's just that we got all this value from it. We have not changed anything to the original list. That must be noted. But if you were looking for this to be assigned to a variable, you can say for instance, nList, whatever name, put like this. So if you check nList now, be having this. Okay? So let's go back again and put this a list. Still the same thing. What other way can you use to get the same thing? I can get that by saying I work from beginning to the end, but you need to go by 5 strides. That is what? In the positive direction, from left to right. I am not reversing anything now for this. Okay? I will still assign it to, let's say, x, whatever variable. So I will now say s.reverse. Then I put this. If I check s now, I have the same thing by using reverse. Either you do this to reverse it, or you simply put this negative, which will do the same work, like what? Reverse. Hope this is clear. Thank you for viewing. Given this, count the number of times 7 and 8 appear. Remove the last item from the list without using remove or del. Arrange it in a steady order. Okay, let's see. This is the given list. Let's just say list equals to this. We are asked to count 7, also count 8, how many times they appear here. So you need to do just a list dot count. Put what? 7. It's 4 times. If we try for 8 now, we have 3 times. You can count it and see. The next one says, remove the last item from the list without using this and this. That means what we are left with is pump. Just a list dot pump. 8 is removed. So if we check list again now, we find that 8 is no longer there. So there's no more 8. The next it says we should arrange it. We should arrange this, okay? So I will come back here, run it again before arranging. If you want to arrange, you have to use the sort method. If we sort, automatically it will be what? In ascending order. If I say let me run from here again to return it back to the format, the original list, then I use sorted. If you want to use sorted. If you use sorted, let's run sorted. See, it's give you error. Why is this error? Because sorted is what? It's a function. That's what I want to clear. If you want to use sorted, you must put it like this. Then you pull this and put inside. Remember, I said it. Sort is a method. Why sorted is what? It's a function. If you run now, it's even giving it to you straight. What if you wanted to do it in descending order? If you wanted to do it in descending order, you can still follow the same thing here, sorted. But you see reverse. This is true. Then it return everything now because the default is ascending. You have to put this to reverse it. See, reverse. What if you are use sort? If I want to use sort on this, Remember, sort is a method, and what we are doing now is we are doing it to turn it to what? Ascending order. But if you wanted it to be descending, you must put this argument. And if you run this again, you find it has turned it to what? Descending order. So it does depend on what you want to do. Hope this is clear. But the question asks us what? To do our work in what? In ascending order. List.sort is enough to get our result. So if I run list again now, I have everything what? In ascending order. Hope this is understood. Thank you for viewing. Given the list, Ahmed has 19 million USD. To unpack to Ahmed has 90 USD. What would you do? Okay, what we have is to unpack this. I'm going to print. This is the list. Ahmed has 19, million USD. If we run this, it's not opaque. We don't want this. We don't want all this. We want it to come out as this. What you should do to conveniently opaque this is to simply put hash before this. And if I run it, you see it's opaque. Okay, this is the solution. Let me show you something here. If I say multiply by 1, you have this. You are using this one as what? As a multiplier, not opaque. If I put this after, error. If I put 1 here, same thing. To unpack a list, simply put what? This. Hope this is understood. Thank you for viewing. Tuple. What is tuple? Tuple is similar to list. The only difference or the major difference is while list is mutable, tuple is immutable. Let's get that. 1. Tuple is similar to list. 2. Tuple is immutable, but list is mutable. For list, you use the square bracket to indicate that this object is a list. But for tuple, you use the curved bracket. Okay? Now, let's look at this particular one, which is the major difference. What this means is that once you assign values to a tuple, assume these are the value of a particular tuple. Let's say the tuple is T1. You can't change these values. That means you cannot add to it, you can't delete, you can't insert, you can't modify. It just remain what? The same, what defined. That is the reason why we say what? It is immutable. You remember when we are treating list, we could copy, add, that extend and append. We could delete, we could remove, we could sort, and so on and so forth. In case of tuple, you can't do all that. In short, the few available methods you will find other tuple are count and index. That is count method and what? The index method. You can still use the min function here. You can use the mass function here. But things like append, extend, delete, that DL, remove, they don't work with tuple because tuple is what? Immutable. Once you assign something, you cannot what? Change it. Okay? With this, let's dive in deeper into tuple. How do you define a tuple? You give the variable name, let's say a tuple equals to, you use the curved bracket, then you put the item you want to put. For instance, I can put 3 for this. So once I say a tuple now, this is how to define tuple. Let's say another tuple, let's say T2. This time I want to put item like A, B. If I say T2, I have this. Let's say T3 again. What if I want to have a mix of these items? If I say T3, it's allowed. Mix of it. What if I define further? So, okay, this time I say this is true. This is a string. This is integer. I say this, any other type of object, let's just put int, and so on and so forth. If I say T4, you have this. That is what I said from beginning, that tuple and list are the same. The only difference is 1. you use the curve bracket to define tuple. Why for list you use the square bracket? Major one is tuple are immutable. Why list are what? Mutable. Any other thing aside this you want to do as you did in list, you can do them what? In tuple. Oh, this is clear. So two things we have defined here now is one, tuple allows what? Arbitrary objects. When you are defining a tuple or when you want to put something in tuple, it allows what? Arbitrary objects. Another thing is that we use this to define tuple. And you can put in whatever you want to put in. The only thing which I'm going to treat next is that tuple are what? Immutable. Hope this is understood. Thank you for viewing. Why we say tuple is immutable? Let's see. If I say T1 is equals to this is a tuple because of the presence of this curve brackets. If I enter, if I say type now, T1, say what? It is a tuple. If I said L1 is equals to, if I enter, I say type L1 is a list. Why? Because this show is a list, but this show that this is what? A tuple. Okay? We have established that. But why did we say that tuple is immutable? Let's try to locate 4. You agree with me to locate 4? We still use the same method. Locating the index, which is 1. It says 1. Let's try to change the value of 4. I'll copy this and paste here. See now the new value of 4 is 9. See what it say? Tuple object does not support item assignment. That is 1. Let me also call this tuple T1, trying to append a value to it. Let's say 10. Say tuple object has no attribute append. What if we want to extend, like tuple object has no attribute extend? Okay, maybe it's okay, we have to put it here. Let's change this one to square bracket. Tuple object has no attribute extend. Okay, you say okay, now let's come back and pick T1 location free. What value is there? 8. Let's try to delete. Tuple object doesn't support item deletion. This is a major reason why tuple is important. It's giving you another option. For list, you can delete, you can copy, you can add, you can modify. If you want to do all that, you are interested in modify something, you are interested in deleting, you are interested in removing, you use list. What if there are some items that are very important? Once you assign, you don't want anything to change them, like the amount you withdraw from your bank account, the deposit you made. There are some data that are critical. You don't want anything to touch. Then you use what? Tuple. Hope this is understood. Thank you for viewing. Tuple items are ordered. How do I mean? If I say T2 is equals to this, if I say T2 now, you see that it is the way I put everything that what? It came out. Because it is what? A tuple. You can see the way you enter the item, that is the way it brought it out to you. If I say what type is this, you agree with me, the type is what? A list. But if this was a set, let's say S1 equals to, and I say S1, you see, it is not the way I enter them that it brought them out. It assisted me in arranging this item in ascending order because this is unordered. Set are what? Unordered. If I say type S1, you find out what? It's set. So with this little demonstration, you agree with me that what? Tuple are what? Ordered. Ordered means the way you enter the items, that is the way it comes out. Garbage in, garbage out. But for this guy set, was to impute something, it will help you to arrange them. Indexing tuple. Let's look at this tuple. Just the way we did it in list, that is the way you use index to locate the item or the element of a tuple. This is index of 0, 1, 2, 3, 4, 5. Just take the variable, put what you want to put here. If you want to locate this, you put 0. If you want to locate this, you put 3. If you want to locate this, you put 5. Let's see. T0 will give us book. T1 will give us pen. T minus 1 will give us this last one. Just the way we saw it where? List. If you want to have this using the negative side, remember for negative side, this one start from -1, -2, -3, just like that till you get to this last one. Hope this is understood. Thank you for viewing. Now let's look at slashing in tuple. You want to get these items or range of these items, or from here to here. We use what? Slashing. Just the way we saw it in list. Let's see. For instance, if I want to get from beginning to the third item, I will simply say T, start from 0 till the third item. That means 0, 1, 2. Don't get to this place. Don't get to what? 3. If I want to get, for instance, from here to here, I will count 0, 1, 2, 3. Let's start from 3 to the end. 3, 4, 5. Okay? To do to the end, I can simply leave this last option out. It means start from 3 to the end. You see? Also, just as you did here, would have done something like leave this one. That means start from beginning to the end. It means the same thing. If you want to get everything, simply say T from beginning to the end. Don't put anything at all. From beginning to the end. Just similar to what? T. What if you want to use a negative value or negative index to slash? I can easily say, for instance, I can say I want to get from here to here. All I will do is to say, okay, this -1, this -2, this -3, this -4. I will say start from -4 to the end. If I pull this one out, I miss, don't get to this place. Okay? Are you agree with me? This is less than this. This is less than this. And this is less than what? 0. So I can simply say what? This to 0. -4 to 0. That is to the end. See? It's giving me from here to the end. Okay? Please do not put 0 here, because you put 0, for instance, so you are using the negative, you will not going to have a result, have empty result. Okay? Hope this is understood. Thank you for viewing. Now let's look at stride in tuple. Stride simply means to move at what? A particular pace. If I want to just move at one pace, just move from here to here, to here, to here, to here, and to here. I will say start from beginning to the end, move just by 1. You see? That's a stride, just one stride. If I want to go by 2 stride, see? It means start from beginning to the end, but move at the pace of 2. That is beginning, 1, 2. That is this, 1, 2. That is this. Can move at 3. Only have 2 now. Start from beginning. This. Move at 3. 1, 2, 3. So when I count 1, 2, it's not up to 3. It's stopped. So now let's copy this again. Let's place it here. And now let's look at negative stride. That is to say, start from beginning to the end. Go by -1. Let's run this. It means start from beginning to the end, but how do I go? Should I go by this beginning or from this side? I say go from beginning to the end. Start from the negative side, that is this side, right to left. So ruler, chair to book, as you can see. Okay? So if I put T here now, you see, T still remains the same, but this side, just reverse it. So now let me go by 2. You see what it has done? It says start from beginning to the end, but you need to start from the negative side. So this is T. This should be beginning to the end, but you wanted to start from here, move to this side. But when it saw negative, came here, then moved towards left. And it went at a space of 2, which is start with ruler, then go by 2, 1, 2, 1, 2, and so on and so forth. Hope you understand this stride. Thank you for viewing. Defining one item for tuple. Assume you want to define just one item for tuple. Let's say 4. You can do this. If you go ahead and do this, you have another type of what? Data. That is 4. Let's see, what is the type of this? Integer. It's not a tuple. So if you actually want to do this, you want to make T1 a tuple, you put a comma here. This is the only way to define what item for what? A tuple. If I run this, I say T1 is what? See the way you brought it out? Then if I say what type of item is T1 now? It's not a tuple. Please note this. Hope this is understood. Thank you for viewing. Let's look at pqy and unpqy in tuple. What is the meaning of that? If I say, for instance, tuple T is equals to 4, 9, 7, for instance. This means packing. You are packing this item into this variable. That is to say, if you look at this place now, we have 4, 9, and 7 house in T. They are house where in T. They are sleeping in T. That's where they are living. Then maybe one day I say I want to unpack. So I want to unpack them to other variables. How can I do that? I will simply do something like this. I say, okay, you, me, and him is not equals to T. What I'm doing now is I am unpacking these guys, unpack this guy to this guy, unpack this guy to this guy, unpack this guy to this guy. You, me, and him. So if you check you today, you will become 4, me will become 9, him will become 7. So this is called what? Unpacking. Now let's see. I mean, if I say T equals to 4, if I put T now, this one me packing. I'm packing all this at T. All these are the guys sleeping in a house called T. I pack them there in the garage, wherever. Now I want to unpack. I say you, me, him is not equals to T. You see? Let me check what U is carrying now. U is not carrying what? 4, the first one. What of me? Me is carrying 9. What of him? Him should be carrying 7. You see? This is called what? Unpacking. Now let me go back and check T. T still remains the same with what it has before. Doesn't mean that you have removed them. Remember, topo is immutable. Okay? So whatever you assign here remain here. Can remove them. That doesn't mean you cannot unpack to other variables, which you have just done here. Remember when we are packing, we did not put this quotation mark. No, we did not. We simply what? Put them direct because what? We are unpacking. That is that. Let's look at another tuple. This time, let's say the first one is cash. The second one is house. Let's say the third one is car. A tuple. If I want to unpack this, I must unpack into 3, not into 2 or into 5 variables. Let me try 5 variables by saying WrTy U equals to a tuple. There are only 3 items here, but I'm trying to use 5 to unpack them. See? Not enough value to unpack because they are not enough. Now let's reduce this one to 2. See? Too many value to unpack. Expect 2. So finally, let's try to unpack correctly. We have only 3 items. We must use 3 variables to unpack them. See, perfect. If I say W now, it says cash. R is what? House. Y is what? Car. Hope this is understood. Very important. What you must also understand is that you don't necessarily need to do this. First of all, assign this to this before you unpack. You can do everything direct. Like, I can come straight to say, you, me, them, us is equals to, let's see, this, 4, right? Packing and unpacking at the same time. Correct. So if I say you now, it's 4. Me is what? 6. Them, us. See, you can do this one with one line, not defining this one separately before unpacking. Hope this is understood. But one thing you must know is that if I want to do the same thing as, okay, I is equals to 3, 4, 6. You cannot, because this is just 2 variables, but I have 3 items. Too many value to unpack. The same thing. Neither can you change it and increase this one above what you are packing in. See? Not enough value to unpack. So finally, if I just want to do this one direct, I'm good to go. I. Hope this is understood. When I'm testing this, I put you and I put I. Why should I be doing that? Can I ask the system direct what is UI? Let's see. UI. Tell me what is UI. It's telling me direct. Let me come back to this place. For instance, all this. If I want to know what is here, I don't need to say you for before me, before them. I can use one line to ask the system. The system will tell me that you is 4, me is 6, them is 7, us is 8. And you can also ask one after the other. Say, what is them? Say 7. Depends on your style. Now let's look at how to swap values in tuple. Assume I pack 10 and 20 into what z. So it's equals to 10 and 20 times y is equals to 10, z is equals to 20. Can I swap this value? Let's see. Now we simply call this one now. I say it's equals to, but I will now write z before y. I enter. Now let's run again. Before now, y was this. So let me put z now. Z is not 10. Before it was 20. Now y is equals to what? 20. But what you should know is that this new y is different from the old y. Let me explain that to you. If I come here, let me use some other value to explain it. If I come here and I say, I want to use j and k to run this. I say now it's 40, 60. I say, what is ID j? It gives me this. Now, I say, what is ID k? Notice these addresses. If I swap, mean k now before j, meaning the value for k should be assigned to j, while the value of j should be assigned to k. I run. Then I come, I say, okay, what is now j? Say j is now 60, but before j was 40. Now let me check the address of j now. J, this address of j. Let me copy it and bring it nearer to this j. Let's see. You see, this address j that has 40 is different from this address j that has what? 60. Let's look for k now. What is the ID of k? K ID is this. That is the address in memory. Now let me come here now. I also compare. See, the address are different. This is just trying to demonstrate what? The immutability of tuple, that they are not mutable. But the next thing you are asking me now, where is the location of this first value? It's still there. Doesn't mean it is deleted from the system. The next thing you should ask me now, since this location is keeping 60 and this location is keeping 40, what of the first address, this and this one? They are still there, they still have those values, but you can't access them because tuple are what? Immutable. Hope you understand this. Thank you for viewing. Let's look at the tuple count method. If this is a tuple, if you want to count any of the element of this tuple, you simply say t1 dot count. Let's say we want to count 6. See, there are 4 6 here. 1, 2, 3, 4. What if you wanted to count 7? See, there are just 2. What about 8? This is how to use a count method in tuple. Hope you understand this. Thank you for viewing. If this is a tuple, let's say A, B, and I want to get the index of D, for instance, I will simply say a tuple index of D. It says it is 3. That is to say 0, 1, 2, 3. What of the index of M? It is 5, and so on and so forth. So whenever you want to get the index of a value in tuple, simply use this method. Hope you understand this. Thank you for viewing. Now let's look at join in tuple. What is join used for? If I have y is equals to this tuple that contain A, B, C, that is y is this. If I want to join all this one together, I want to join A, B, and C to have A, B, C. So I want to have something like this. How do I get this? I will simply say this dot join. Then I put the variable. What is the purpose of this? This is the place that this join will be looking at. So I'm telling join to look at this place or want to put in between A, B, and C. Let's see. You can see now there's nothing here. There's no space. There's nothing. That is why when join was merging these 3 strings, it joined them without spacing them. If I put space here now, I run it again. You see, there's a space here now. If I put something like hash or $, I run $in between. If I put at sign, see, at is between. If I put R, something like this, I put hash. See? So this is the place that join is looking at to join all this together. Okay? Hope this is understood. Thank you for viewing. Write a Python program to create an empty tuple. The question says we should write a Python program to create an empty tuple. And if you want to create an empty tuple, you use this curve bracket. That's all. If I check T now, it shows me this. If I ask what type of object is this, it say what? It is a tuple. Okay? If u equals to this, assign the third element to a new variable u3. We are talking about this element. How do you do that? You simply say u3 is equals to, then you give the location by using u, then you put the index, and the index was 0, 1, 2. But before we do this, we need to first of all run this. We run this, then we cannot run this. If we check u3 now, we have 8, which is this one. This is how to assign element from existing tuple to a new variable. Print the last element from this tuple, u equals to this. How do you do this? This is a tuple. We want to print the last element. Last element in tuple is also written as -1, just as in list. This is how to print the last element from a tuple.
It's break time. Do you like this video? Don't forget to subscribe to get new videos. Share this video to open new premium videos and ebooks. We'll be a star freelancer.
What is the index of 6, 7, and 8 of this tuple? To do that, you simply say s.index, then you put the element. The first one is 6, that's 0, 1, 2, 3, 4, 5, 6, 7, 8. The next one is, we should get for 7, 6, 9, should get for 8, set is 1. Hope this was also your solution. Thank you for viewing. If k is equals to this, how many times does 2 appear? That is to use what? Count. If you run this 2 times, 1, 2. For instance, you want to check like 17. What time? You use what? Count. Write a Python program to create a tuple of mixed data types. Let's say a tuple is equals to, let's write 3, 6.7, that's a float, a string, int, a float. So let's check a tuple of varied data types. Sum all the elements of this tuple. If you want to sum all the elements of this tuple, we first of all run this, then we sum them. That's 67, using the sum function. What is the minimum and maximum values of this tuple? So let's run the tuple. To get the minimum, use the minimum function, the min function. That is 2. And to get the maximum, use the max function. That is 10. If k is equals to this tuple, unpack k. If we enter to unpack k, we simply look at the number of elements in k. And we have what? 1, 2, 3, 4. Let's say k1, k2, k3, k4 is equals to k. So this will be assigned to this. This will be assigned to this. This will be assigned to this. Why this will be assigned to this? Let's see. If I ask for k1 now, see, it's 5. The first element. If I ask for k2, it's 9, the second element. If I ask for k4, it's 41, the fourth element. Hope this is understood. Thank you for viewing. Now let's look at how to swap values in tuple. assume I pack 10 and 20 into what z, so it's equals to 10 and 20. That means y is equals to 10, z is equals to 20. Can I swap this value? Let's see. Now we simply call this one now. I say it's equals to, but I will now write z before y. I enter. Now let's run again. Before now, y was this. So let me put z now. Z is not 10. Before it was 20. Now y is equals to what? 20. But what you should know is that this new y is different from the old y. Let me explain that to you. If I come here, let me use some other value to explain it. If I come here and I say, I want to use j and k to run this. I say now it's 40, 60. I say, what is ID j? It gives me this. Now, I say, what is ID k? Notice these addresses. If I swap, mean k now before j, meaning the value for k should be assigned to j, while the value of j should be assigned to k. I run. Then I come, I say, okay, what is now j? Say j is now 60, but before j was 40. Now let me check the address of j now. J, this is address of j. Let me copy it and bring it nearer to this j. Let's see. You see, this address j that has 40 is different from this address j that has what? 60. Let's look for k now. What is the ID of k? K ID is this. That is the address in memory. Now let me come here now. I also compare. See, the address are different. This is just trying to demonstrate what? The immutability of tuple, that they are not mutable. But the next thing you are asking me now, where is the location of this first value? It's still there. Doesn't mean it is deleted from the system. The next thing you should ask me now, since this location is keeping 60 and this location is keeping 40, what of the first address, this and this one? They are still there, they still have those values, but you can't access them because tuple are what? Immutable. Hope you understand this. Thank you for viewing. M is equals to this tuple. J is equals to this other tuple. Make the third to the last element of J the last element of M. What it's saying, the third to the last element, which is this, third to the last element. What it's saying is, this element should be here, something like this. That's what the question is saying. How do you do this? Let's first of all run this. M. We run this too. These are the two tuples. This is very important because if you have a tuple that has millions of elements, you will not be able to count like 1, 2, 3, 4, 5, 6, 7, no. Or 0, 1, 2, 3, 4, 5. No. The question says third to the last element of J should not be what? The last element of M. All you need to do is new element in M is equals to the old element in M plus J minus 3. To do it now, you put this bracket. The reason for this comma is because this one will produce the value of 10. If you look at it now, for instance, here. It's 10, right? You can't just put 10 straight here without this comma. If you do this, this is no longer what? A tuple. We have actually treated this. You can look at this. You have to put the minus. That was what we did. And if you check M now, you find out what? 10 is now included as one of what? Its elements. There's a second to the last without this. You see? Error. It means whatever this one will produce, that is 17, is integer. It's not a tuple. For this to be a tuple, there must be a comma. This one makes it what? A tuple. If I undo, I put comma here now. See, accept. If I check M again now, you find out what? This value 17 has been what? Included. Although this is not what the question asks us to do, it only needed what? 10 to be included. But just to demonstrate to you, that is the reason why I have to what? Go further to work on this with 17. Hope this is understood. Thank you for viewing. If y is equals to this, convert y to a string. Let's see. If y is equals to this, convert to y to a string. Let's say string now is equals to this dot join. You use the join method. Y. If you check string now, you find what? It's now what? Python. Use the what? The join method. Hope this is understood. Thank you for viewing. Without assigning this and this to any variable, get the second and second to the last elements from the first and second tuple respectively. Okay? Without assigning them to any variable. So I'm going to call this, okay, put comma. I also need this second to the last element. I print. See? This is the second element. This is the second to last. Can see them? Without assigning them what? To any variable. Remove 4 from this tuple. This is a tuple. We are asked to remove 4. If we want to remove this from this tuple, it's a matter of picking this and this to form a new tuple. Let's see. I said the new tuple is equals to T. I get this one out of this place. That means beginning to this place. I don't want it to get to this place, which is 1. That is to say, start from beginning, don't get to 1. Remember, don't get to this position. Don't get to 4. Plus T again, it means start from this position to the end. This position is 0, 1, 2. Start from 2 to the end. This 4 will be avoided. See? We now have 5, 1, 2, 6, 9. Hope this is understood. Thank you for viewing. What is the length of this tuple? Okay, let's get a tuple. We need the length of the tuple. Simply use this function. Okay, given x is equals to this tuple, get 10, 5, 2, and 8. That is this, this, and this. What is the meaning of this? It means we're going to pick this element in a reverse order. If we start with 10, it will go by 3, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. Okay, let's run this. When we run this, we simply say S now. We use the stride minus 3. Exactly. Hope this is understood. Thank you for viewing. Look at this tuple. Programming is hard work. Adjoin its strings together to achieve programming is hard work. This is string, this is string, this is string. We want to join them together to achieve this. How? If you want to join this together, you simply, first of all, we need to know what is the tuple. So we put the tuple here first. Programming is hard work. I enter. If I put S here, I have this. I want to join them together. To join them, you put this. Because there are spaces in between them, I will put space here. Then say dot join. Then I put S here. See? Programming is hard work. Hope you understand how to use join to connect different strings in a tuple together. Python dictionary. What is that? Python dictionary. In computer science, there's something we call associative array. Okay? This array has to do with what? Keys and what? Values. Or you simply say what? Key, value, pair, type of what? Data. For instance, these are names of people. The first one is Anne. Second is Tony. The third person is Peter. The age of Anne is 50. Age of Tony is 40. Age of Peter is 35. I can use this and as key, associate it with this value 50. The same thing with Tony, associate to what? This value 40, Peter to 35. Remember when we are doing list and tuple even set, you see that you can go ahead and define what you want to define, 1, 2, 3, or you use your square bracket, say 5, 7, 8, whatever. But here, when you want to define dictionary, you must measure the key and the value. It's like a house. Now, before you enter the house, you need a key here, okay? This key is what you use to access this house. So assume I put 50 here now, and the key to enter this house is "and." Without this key, you can't enter here. It means without this key "and," you cannot access 50. The same thing with 40 and 35. So they are in different houses. I'm using this illustration so that you understand better. This another house is 40, and the key to go in is called Tony. When you collect all these into a data type, that is called what? Dictionary in Python. And what you must know about it is that what? They are ordered. Ordered in the sense that the way you put in the data, that is the way you have them back. Hope this is understood. Let's go in and see how to define dictionary in Python. Now let's see how to define a dictionary in Python. There are two ways, and we're going to consider those two ways in this lesson. If I want to define a dictionary, I put the curly bracket. Remember, the curly bracket in Python is used to either define set or dictionary. That's what it's for. But to show that this is a dictionary, I must use the semicolon to separate what is at the left from what's at the right. Left is the position for the key, say "and right is the position for the value. Say she's 50, I say comma. Remember, dictionary is a collection of what? Objects. I said the next species is Tony. The value is 40. So the next species is Peter, and the value is 35. See? Key value, key value, key value. Let me assign this to a variable D. If I enter D now, it's giving me this. And what you should notice is the way I type it in, that is the way it's bringing it out. That means it is ordered. Let me ask the system, what type of data is this? It says dictionary. Okay, this is how to define dictionary in Python, the first method. But remember, we put this quotation mark here because this guy is a string, this is a string, this is a string. Assume we say, okay, let's do for D2. This time, I say, I want to use number as my key. I say 4 goes for Mike. I say 9 goes for John. Let me leave it here. I enter. D2 is giving me this. Type is giving me what? Dictionary. This time, this is a key, this is a value. This is a key, this is a value. Okay? It's not because there must be integer and string or string integer. You can do either ways. If I say D3 now, I say it's equals to 3, 10, 4, 1, 2, 20. It's allowed. D3 type, still dictionary. I can even go ahead and say, okay, D4 is equals to, this time, U. Very good. Comma to separate for the next one. Me. Also good. I enter. D4, you see, type, dictionary. You can do as you want. Great. Which other method can we still use? We can use the Python built-in function called dict. With this function, you can also define what? A dictionary. But what will be inside now will be what? List of tuples. What do I mean by list of tuple? If I put this now, square bracket, what is this? It means what? It's a list. Okay. If I put this, it means what? It is what? A tuple. So if I do something like this now, I say and, comma, 50. I put comma here again. I say Tony, comma, 40. Put comma here. Peter, comma, 35. I will call this one now. Let me say KK equals to this. Remember, this is enough to be what? A tuple. If I put this out, let me just put it here. This is a tuple. So these are list of tuples. Sure, it's a list of tuples. I can convert this to a dictionary. You are telling the system that this is not the key, this is the value. Let's see. If I say KK now, see, it's not returning it as if I use the curly bracket from beginning. Let me ask the system, what type of data is this? KK. You say what? Dictionary. You see what we have done here? We can do it in another way. Let's just call this one KK2. Dictionaries remain. We are going to remove all these tuples. See, tuple, a tuple, a tuple. What are we going to introduce this time? We are going to introduce string format. Assume I say, okay, Anne is equals to 50. Tony is equals to 40. John is equals to 60. Luke is equals to 25. Something like this. Let's run this. Let's see KK2. Remember, here I put what? Quotation marks. Here I put Anne without quotation mark equals to 50. Okay? Let me find the type of KK2. See, it's a dictionary. Let me say KK3. If this guy was, I will buy high house. I will buy this guy a car. We're going to buy this guy landed property. This one we get what? Books. Now let's see. KK3. Still same, right? If I say type KK3, you have dictionary. Now let's go back. When I did this, I never put quotation mark here. But when the system was returning it, see, perfectly, there's what? Quotation mark. Quotation mark. Great? Good. Here, when I define this one too, I did not put any quotation mark because I know the system understands that with this dictionary, it's going to merge these two together. Look at this. Why? Because this is a string. This is a string. This is a string. If this guy, let me go for 4 now. If this guy was an integer, just like here, there is no need for that. Let me leave this one like this. Let me run this one again. See? KK4 now. See? It's coming what? Perfectly. Remember, all this is done because of the presence of this and this. Okay? But if you're not going to put this, you must put the tuple method. Why use dictionary? Then you make sure that it's a list. This one means a list. That's a square bracket of these guys. 1, 2, 3. Let me recap so that make sure you understand what we are doing. The first method, you use the curly bracket. With curly bracket, you give us the key followed by the value. If the key is a string, you must put the quotation mark. If it's an integer, there's no need for that. Then you put what you want to put. The second method is to use the dict function. I will find that this will add on list of tuple. So I said it's a list of tuples. See, tuples. I use comma to separate it. List of tuples. Here I put the key, comma, the value. Key, comma, the value. Key, comma, the value. Key, comma, the value. This one is the first option. The second option, see use a dict. This time, I don't need this guy. I don't need this guy. I don't need them at all. I don't need them. Why I don't need them is because I want to use equal to. Okay? How do I do it? I say the key equals to the value, comma. The key equals to the value, comma. The key equals to the value, and so on and so forth. And I told you that here, even though this is a string, just put it. It's like and don't need to put the quotation mark. The system will help you to do that. Unless if it's on the value side, then you put it. On the key side, no need for that. But on the value side, there's need. Okay? If I come here again, for instance, I do this. I say here is 1. You see what will happen now? Here is 2. Here is 3. Here is 4. See what will happen now? See what happened? Expression cannot contain assignment. Perhaps you mean this. This is wrong. Unless what is here is what? A string. Let me just say A, B, C, D. Accept. Before I put, let me put 3 here again, put 6 here, put 9, 8, put 7. Let me even remove this first one so that you understand what I'm saying. If I run this, still complaining. Hope you are getting it now. You see the varieties. Because this is a string, it accepts by default. With this, it knows what you are talking about. For instance, now if I come to this place, I say, let me enter this. But this time, I know actually that this is a string. I remove it. Look at what will happen now. It won't go. Name car is not defined. See? This is not defined. If I put quote now, it's not defined. Hope you understand the difference. These are very important. These basics are very important. A good foundation will catapult you to become a very good programmer in Python. Hope you understand this. Thank you for viewing. Let's look at how to define dictionary with arbitrary values. What you are seeing here now is a key from string, then we put list. Okay? This is another string. Here is what? A set. Here is a string. Here's what? Set of tuples. This is boolean. This is a string. This is integer. Even the key is integer. You have flexibility of doing things like this with dictionary. Let's run this as C. If we find what is F now, see the entries in F. So this is not written on stone. You can put random values as it comes to your mind. There's no boundary at which you can go, as long as what the keys are perfectly well selected. You see the key here now is integer. It allows you. It all depends on what you want. So you have freedom of choosing what you want to put. What if you also want to put in a sub dictionary? This is a sub list because it's a list inside dictionary. This is a subset. This is what? A subtuple. Can we also put a sub dictionary? Of course. Let's say DD is equals to a sub dictionary. That is what? Let's say K to V, M to C. Put F again now. We find out what? DD has what? Value that is sub dictionary. This is to let you know that dictionary is so flexible that you can put whatever you want to put. Either a list, tuple, another dictionary, true, false, string, integer, any data type. You can just throw it in. Dictionary will dive and catch it. Hope this is understood. Thank you for joining. How to access dictionary values. If you want to access dictionary values, how would you do that? Let's first of all write a simple dictionary. This is a dictionary and you want to access its value. Remember, it's key value. Key is meant to access something. That's why it is called key. Use a key to open a door. Use a key to close a door. So for you to access any of the value, which are 89, 30, 34, this is a key you can use to access them. How do you do that? If I want to access the value of James, I simply say D, then I put James, which is the key, with what? The quotation marks include. If I enter, I have what? 30. You want to access the last one, you put Kate. You enter, you have 34. Note, you don't access the values of dictionary with the index. Like you put something like this one, you cannot. It's giving you error. As you can see, this is not possible. You can only do this with tuple or list. When it comes to dictionary, you must access the values with their keys. Hope this is understood. Thank you for viewing. Added to and updating existing dictionary. This is an existing dictionary. We want to update this, for instance. As you want to update this to 10, how would you do it? I will just say D to access it. I know I have to use the key with the shirt. Then I put the new value to 10. If I check D now, See, this is a new value. That is how to what? Update. Assume I want to add to this dictionary a new entry that is not here before. Just say D, for instance. Books can simply say equals to 4. Accept. If I check now, there's a new entry called what? Books. Hope you understand this. This is how to update and add it to existing dictionary. Delete existing record. How do you delete existing record? If I say D now, these are all the existing records. Just say del to delete it. Then you specify the key that you want to delete. Assume I want to delete trousers. Just specify, that's all. I enter. If I check again now, find out what? It is gone. So whenever you want to delete, simply do this. Okay? Incrementally building a dictionary. As the saying goes, Rome wasn't built in a day. When you have all the information that is required to build a full dictionary, it's okay. But there are some times you don't have any data available and you draw out the design of your software that the particular data type that will be here is a dictionary. So you have to make it available by simply say, for instance, you can do something like this. Let's say student dictionary. This is a dictionary. But the only thing here is that this is an empty dictionary. So if I say type student, see what? It's a dictionary. If I put the student back, notice in this dictionary, how do I start building it now after I declare it? I can make the first one, say the name. I can say the name of the student is Paul. I come back again, say, okay, the age of the student is 30. What of the books he has? I can say the number of books, 10 books. What about the courses he registered for? I can say courses. Come here now, build a list of courses. I can say mechanics. Next one is advanced physics. I can put advanced maths, etc. Now let me check student again. You see, the name of the student is Paul, age 30, number of books 10. These are the courses what he registered for. You can see that this one is what? A list, which is allowed. What if I ask if the student is what? Active or not active? I can say active, for instance, put true or false. If I check student again, see, allowed, boolean. So it all depends on what you want. So this is how to build a dictionary incrementally. It is allowed. Whatever you want to add, you throw it in. You just throw it in. Continue to throw it in until you get to millions of what? Entries. Hope this is understood. Thank you for viewing. Let's look at how to access sublist or sub-dictionary. How do you do that? I have this course student, which is this. And I have this as what? A list. Inside what? Dictionary. So this is called what? A sublist. How do you access any of the value in this dictionary? If you want to do this, it's not like the way you would do this one. Like if I want this one now, just say student, put name. I have Paul. So if I want to access this, I will still put these courses. Okay. If I drop this first, I have this. But I want this for now. To get this, I have to tell the system the location. That's to say 0, 1. Okay, it is 1. See? This is how to access it. If you want to get this advanced maths, it's a matter of doing this. Say -1 to get the last one. For this student now, let me say student. Let me add another entry. Let's say course. It's equals to. This time I want to use another dictionary. Let's say this course 80%. Let's just say 80. Advanced physics. Let me just copy fast. Let's say 67%. Let's see advanced maths. The score was 90. Then I enter. If I put students again, I have this as sub dictionary. That dictionary in dictionary. So if I want to access this course now, I can say student. I want to access this course. It's giving me this. What if I want to get this or this? All I need to do is to specify the location now. And to specify the location, remember that you can use IDES to access list, but you cannot use IDES to access dictionary. If, for instance, I put 1, okay, that is 0, 1. If you think like that, you're going to have error. See? It's not allowed. You must use the key. What is the key? This is the key. You have to put the key. You see? You have what? 67. Okay? If you want to get the last one, say you want to get this last one, you go ahead and put -1. the way we do for list, that is for this, you're going to have error. It's not allowed because this is dictionary only allows what? Key value. So I put what here? I put advanced maths because that is the key. Dictionary does not allow index but allows what? Keys. Hope this is understood how to access what? Sublist or sub dictionary. For sublist, use the index, you can see here, but for sub dictionary, use what? The corresponding keys. Hope this is understood. Thank you for viewing. Thank you for viewing. Dictionary key restriction. We agree that a dictionary is key value pair. That is to say, I can have a key, then have what? A value. I want to see the restriction here. Because what we have seen so far is that we can throw in anything, but there are some restrictions we need to look at. The first restriction is that you cannot use mutable object for the key. How do I mean? List is mutable. You can't use list as a key. What is mutable again? Dictionary itself is mutable. You can't use it what as a key. Let's see. What you should use as a key are the immutable object in Python. This is a string, for instance. You can use it. If I run this, I put this k is equals to this, I will have k perfectly. Let me use f this time. I can do this. Say h link to what? 19. If I can say 10 because it's immutable, integer. Link to 1000. It's allowed. I'm talking about the key side. Just put your mind here. For the value side, there is no need to worry because you can put any object you want to put, whether mutable or immutable. It doesn't matter. What is immutable again? Tuple are immutable. Can put 8, 9. This is tuple. Link to, let me say hello. Or I put another tuple. For instance, I say A, B, C. Why are you doing this? I'm just doing it because I can do it. It's allowed. You see? If I run this, no rejection or accepted because what I'm doing, I'm using immutable object for the key. Now let me try H. So okay, now I want to use list as my key because I am stubborn. I must use list. Let me put 10. I use another dictionary this time. Remember, dictionary is also what? Mutable. I will do something like this. Let's see U, link to 2. This is dictionary. This is my key. Then I put the value, let's say 20. It's not allowing me on hashable type list. It's coupling of this. Okay, let's remove this. Remove this. I'll see if it will accept this dictionary now. Dictionary in dictionary. Let me just put this one like 10 to 10. Remember, you can put float like 3.2 to, let's say, A. Let's see what we do this. Let's see. On hashable type dictionary. It's talking about this again. So let me now copy this. I remove it again. So if I remove this one now, this is immutable. Immutable. Let's see now. Accept H this. See, that's one of the restrictions. Do not use mutable object for the key in dictionary. I will say that. Another thing you should know is that this 10 is already used for this key. So assume I say G, for instance. If I try to use 10 again as a key for another thing, it's not allowed. Let's see this, for instance. Now let's run G. See? Though here there's no error, but this wasn't accepted because when it started, it saw this accepted. It saw this accepted. Python came here. I found that A that it accepted before is now used for another value. It will discount this. I replace this one now with this. How you will know that this is true is this. You agree with me that if at all, this should be arranged because it's ordered, B should come before this. But why is it that this one now is not coming before B? The reason be that he accepted this, I put this somewhere here. He took this, I put it somewhere here. So we found this again now. I found that what? What it chose before, A1. This one is just for replacement for the first one. Okay, it's replacing this first one with this. So it will still take the same position. Okay, let me show you another thing. If I copy this, I put J here. If there was no A1, if I run this, I put J, you find out what B comes before A. But in this case, this one is coming before this because he accepted this one quite right and made this one the first pair in this dictionary. to this one second pair. When he found that the same A is being used, is interpreting this as the programmer of this line is telling me to replace this value with 3. It's not asking me to delete this guy. It's only asking me to replace the value with 3. That is why this one now, which you think is this, is coming before this one. Again, do not use the same key in the same what? Dictionary. Hope this is understood. Thank you for viewing.
This video is over. Go to starfreelance.eu to download these videos, materials, and sources. Watch more videos to get premium videos and ebooks. We'll be a Starfreelancer.